Everybody, I am so happy to be here. I am so happy this morning, and do you know why I'm happy? Because this morning I woke up in Grenada. The last 7 mornings I have woken up in Grenada, and it makes me happy because you are beautiful, the people of Grenada are beautiful, and the island is beautiful. But I'm even happier than that because I'm with you today, and we are together today. Welcome, my friends. Welcome, boys and girls. Welcome, men and women. Welcome to our community. This is CaribNOG, the Caribbean Network Operators Group. This is the 25th meeting of the Caribbean Network Operators Group. A network operator group is a community of people who come together because they care about how internet infrastructure works in a region. Here, it's about building and growing and evolving internet infrastructure in not just the Eastern Caribbean, not just the West Indies, but the entire Caribbean region. We start our meetings like we always do. We start them with thanks, and we start with a prayer. So if you would all be so kind as to please stand up, the wonderful Claire Craig is going to come up and give us a prayer to start our day.
Thank you, David. Good morning, everyone. Father, we just lift you up and we thank you for CaribNOG 25 and the Grenada ICT Week. We thank you, O God, for what you have done for this entire week and where we are today. And we pray that your presence, O God, comes into this room and inspires these young people and those online, O God, to take in all that you have in store for them, O God. Father, allow them to see the beauty of why you have brought them here and the opportunities that are available to them, O God. Father, we lift them up and we thank you for their curiosity and we thank you for their willingness to participate, O God, and we thank you for their enthusiasm. And we ask you, O God, to continue to bless them. This we pray in Jesus' mighty name, amen.
So we spent this week in this room, and we had this meeting called ICT Week. And we brought together, here in Grenada, we brought together leaders in the business community. We brought leaders in the public policy community. And then yesterday we had a whole tech community here, and we talked, and we shared knowledge. And we talked about our dreams and what we can do and what we can actually build. And all that is to lead up to now. Today, my friends, you and I, individually, you are going to build an ISP, an internet service provider, from the ground up. We're going to let you see there are laptops on these tables. We're going to open them up together in a little while. And we're going to open these up, and eventually you're going to be a blank command prompt. And from that command prompt, we're going to build an ISP. We're going to turn it on step by step. And we're going to do it in a way so you see what's going on and you understand what's going on. And we're going to explain it. And at the end of the day, when you go home, you're going to be able to tell your mom and your dad and your friends and your teachers, I built an ISP today. Why are we doing that? Well, I need somebody to raise their hand. Come on, somebody raise their hand. There you go. I saw you. So tell me, my friend. I'm David. What's your name?
Hezron Agad.
Hello, my friend. Tell me, when you pick up your phone and you go to somewhere on the internet, what's one place you like to go to?
YouTube.
YouTube. Good example. So you pick up your phone and you use the YouTube app, or you go to youtube.com on your web browser, and you know what happens, right? The video plays. Well, how did the video play? Well, they stored the video somewhere, and it goes through your ISP, and it gets to you, and it works, right? Well, we're going to teach you today exactly how it got from the server, wherever in the world it is, where the video is, and all the steps it took to get to your phone or to get to your computer. Because technology is easy, right? We can get to sites, we can do things, some of us know how to code, we can do all that, but do you know how it really works? Today we're going to do that. Today's made possible because we've had a community come together to form a meeting. And I want to just thank some of those people very quick before we start. I want to, of course, thank our friend, Mr. Bevel Wooding. Bevel is the executive director of CaribNOG. Bevel and his organizing committee have worked real hard, so thank you, Bevel, this week. I work at a company called ICANN, the Internet Corporation for Assigned Names and Numbers. We're responsible for coordinating the domain names that you use and the IP addresses behind them. And with me are my colleagues from ICANN, Ms. Nayela Saras, and one of our teachers today, Mr. Nicholas Antoniello. NANOG. NANOG is the North American Network Operators Group. They've helped sponsor this today and be here. Our friend Aaron Atach, he's an engineer at Akamai, which is a big content delivery network. He's here today to help us teach. I need to thank the folks at the Caribbean Telecommunications Union, the Internet Society, LACNIC, the Grenada Chamber of Industry and Commerce, and our friends at ARIN, the American Registry for Internet Numbers, which coordinates the IP addresses when ISPs and schools and enterprises need IP addresses here in Grenada. Okay, let's go to the laptop. Let's switch the presentation, please, because I want to introduce myself and I want to introduce your other teachers today real quick. So, I am Mr. David. You can call me David. And that's another thing about today. This is CaribNOG. And today, we are all CaribNOG. You are CaribNOG. And part of being in CaribNOG is we can go up to each other and we can say, hi, I'm David. Can you help me? Or I have a question, or I just wanted to meet you. So today, as you see people and as you talk to people, if there's someone you want to meet, just go up and say, hi, this is my name. I want to talk to you. I'm Mr. David. That's me. I'm here today from Washington, D.C. If you have any questions, please raise your hand and I'll answer them. Our next teacher is Mr. Aaron Atach. Aaron comes to us today from Chicago, Illinois. And this is our third teacher, Mr. Nicholas. Mr. Nicholas comes to us from Montevideo, Uruguay. David, Aaron, and Nicholas. We will be team teaching you today. Okay, it's time. These are the people in the room. Let's go ahead and spread out just a little. If a couple of you, we're going to share some laptops, but if a couple of you don't want to share, we have a couple of open laptop there, a couple open laptops there. If just a few of you want to spread out, if anyone feels like it, come on, don't be shy. All right, what we're going to do now is we're going to unbox our laptops. So I want you to take the laptop that's in front of you. If you want to share with somebody, you can share. I want you to just open the box and take the physical laptop out and put it on the table, please. And this is why we're spreading out, so you can have your own laptop. There we go, guys. One more. I got two there. Here's another one. You don't have to share.
Check.
So what we are going to do is, after you unpack everything, there should be at least the Chromebook, the power cable, and the power stuff, you know, just like three pieces of hardware, and then leave the box with all the stuff inside on the table, so we will collect the boxes, so we clear the tables, okay?
Okay, there we go. All right, as we finish the unpacking, go ahead and find the power button and turn it on. And let's see how much battery you have. When you get an indicator of how much battery power that is, somebody tell me. 0? Okay, we have plugs. Start plugging in. There are power strips below all of the tables. You guys might have to move. Oh, it's behind you, is it? Okay, you guys got one. All right.
We expected them to have some.
We were hoping they had like maybe 50%. Well, sometimes they come fully charged, like the iPhones, fully charged. All right, plug in. Everybody plug in. If you have problems, just raise your hand. Get my attention. Okay, so we've got 50 laptops open and we're about to connect them all to the wireless. That's a lot of devices to quickly connect to a wireless access point. So to all of you in the audience who have been here this week, I'm talking to mostly the adult observers, I would like to ask you to please disconnect your devices from the ICT wireless network, just for a little bit, please. Please take your phone out, please disconnect it from the wireless if you can. I always want to make sure all the laptops can get on the wireless and the access point doesn't melt. Okay, we're at a Get Started page. Next up, we need to connect to the wireless. This is the wireless network in this room. You're going to connect to ICT 2023. There is the password. It is case sensitive. One of the important things for today, my friends, is we have to work as a team. We're all friends here. We're going to work as a team. I'm your teammate. The person next to you is your teammate. Here's the thing. If you see somebody next to you who's having trouble, help them. As we're going through this course, we're going to be typing a lot of commands. If you see someone having trouble, please help them. If you need help, raise your hand. We will help you. But let's work together as a team, please. All right, I see people connecting to the internet. It's going to check for updates. Excellent. As you get to the next screen, when it's done checking for updates, you're going to log in either with your existing Google account or you just need to create a new one. If you don't have one, it's fine. Just create it with a username and a password. You can use it again in coming days. You don't have to ever use it again. It doesn't matter. It's just so we can get onto the Chromebook and start using it. So access the wireless network and then create a Google account or log into yours.
If you get a notification for Chromevox, you can just say no and skip that part.
That's what I was going to say. So again, just to remind us all that we try not to connect to the Wi-Fi network any other device other than the Chromebook. That is to make sure that we leave all the bandwidth and all the access capability of the network for the Chromebooks. If we start connecting all our phones, all our devices, the network may fail and we are lost. So we want to just go smooth with the lab, okay? Also, just as a comment, because we all want to test stuff, during today's session, we will ask you to go together, all together, step by step. It will come a time when you will feel a desperate need of trying stuff. Just try to wait for everybody and let's go again. Let's go step by step, okay?
Okay, thank you for your patience. We had another bus come, getting everybody situated. Welcome. For those of you who just arrived, welcome. I'm Mr. David. This is Mr. Nicholas, and this is Mr. Aaron. And we're going to be building an ISP today on our laptops. If you're new to arrive, please sit down next to someone with a laptop and you're going to be sharing. So all the laptops connected, everybody's good? All right, we should be now. Okay, so you should be in front of a web browser, a Google Chrome web browser. Is everybody there? Okay. I want you to navigate to the following URL that's on your screen, caribnog-r.te-labs.training. I want you to go ahead and navigate to that URL and then stop once you get there.
It will prompt up.
Okay, my friends in this row over here, this is a hands-on activity, so please go ahead and spread out, find a laptop, grab a chair, sit next to, make a new friend, and what I want you to do when you're sharing laptops is I want you to please share. Sometimes you type, sometimes let your neighbor type. Work together as a team, but please, everyone should be in front of a laptop. There's plenty of space on the other side of the room too, my friends. If you want more space, there's space in the middle. These guys in the front, they have 4 laptops they can share with you. Just don't be shy. Sit down, make a new friend. Okay, so please ensure you go to this URL. It's going to pop up a box with a username and password. Please put the username and password into the box.
Remind them to wait there. Do not click on any.
Once you have put the username and password on, please do not click on anything on the next screen. Perfect. I'll put it back, 1 second. We need the username and password still, please. Okay, so you're going to go ahead and click more ways to sign in. Edward, did you put that in there? Yeah. Okay, so enter your password. Yeah, go ahead, put your password in.
So if anyone is still trying to put on the username and the password and you need help, just raise your hand and we will help you, okay? This is for you, so don't feel any shame of asking for help, okay? Asking for help, it's always good.
Hey everyone, real quick by a show of hands, who actually brought their own laptop? Okay, so for the folks that actually have your own laptop, all of this is accessible over the public internet. So if you don't mind, just due to how many people we have in the room, if you can use your own laptop, if your table effectively doesn't have enough Chromebooks, and then we're going to go back 1 slide and you can log into the Wi-Fi if you don't recall. So just once more, if you actually did bring your own laptop, it seems like actually a few students did, please feel free to bring it out if you don't actually have a Chromebook that's accessible for your own use. All of the training that we're going to be doing today is over the public internet, so all you need to be able to do is connect to our Wi-Fi, which we're going to pull up those credentials just in a second here.
So for those of you using your own laptops, there is again the network and the password for connecting to the Wi-Fi, okay?
We have to just be patient just a little bit more. One final bus has just arrived. We're just going to just sit, chat, relax for a few minutes. They're coming in right now. We'll get them seated. We do have a few more laptops.
Come in, they lose 2 laptops. So you can take 2. If you need to take 2, you can take 2 from this table.
Okay. I think that's it, yeah.
Go ahead. Okay, I think testing. Okay. Morning again. My name is Bevel Wooding, and I just want to find out for those who just got in, my orange shirted friends, where are you? Laptop not good over there. They appeared? Oh, you got. Oh, you're good then. We didn't say so. We didn't say so.
Okay, if you've just arrived in the room and you have a box in front of you, please open the box and take the laptop out, please.
Can we get back the slide with the Wi-Fi? Yeah, we're done. So we don't need to take out anymore. No, they're good. They're all paired up.
They're all paired up?
Yep.
Okay.
Yeah, we good.
Go put it in the
All right. There you go. Thank you.
Is there anyone still wanting to connect to or trying to connect to the Wi-Fi network? Raise your hand. Okay, so I guess everybody is now connected to the Wi-Fi network. Then, after connecting to the Wi-Fi network, again, go to... Okay. Just go to... that URL, CaribNOG RT Labs training. It will pop up a username and password prompt. Use that username and that password to log into the lab. Once you log into the lab, you will see a screen with many links. Please wait there. Do not click any link on that page, okay? We will wait till everybody is in the same page, and then we'll continue from there.
If you need assistance, feel free to raise your hand. We'll just walk over.
Okay, I think, my friends, we are all set. Is everybody at Nicholas, can you put up the screen? Is everybody at the screen that says welcome to CaribNOG Trainings Lab, routing BGP?
Show of hands, who isn't?
No, hang on. Oh, take your time. Nice, good. Okay. I'm going to redo 30-second intro again. Okay, thank you for your patience, everyone. So to all of you who just joined us, and I see a lot of people in orange shirts, welcome, welcome. I am Mr. David. If you have questions for me, say, hello, Mr. David, I have a question. Also with us today, who will be teaching, is Mr. Aaron. Mr. Aaron's from Akamai, a big content network. He comes to us from Chicago today. Also with us teaching is Mr. Nicholas. He's the really, really smart one. Mr. Nicholas comes to us today from Montevideo, Uruguay. I'm David, this is Nicholas, this is Aaron. We're all a team today. So raise your hands, call out loud, hey David, and let's work together. We are building an ISP. Whoops. We are building an ISP today. You're connected to the wireless. You should all now be here. Now we have to assign you a number. You need to remember this number for the rest of the session, okay? As you see on the screen, it says Group 1, Group 2, Group 3, Group 4. I'm going to assign you your numbers. You will need this number when you're typing, okay? So, you are number 1. You are number 2. This laptop is number 3. You are number 4. Please don't forget this. You are 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You are 15, ladies. 16. You are 17, 18. When I'm done, you will click on your number, but not until you're done. You are number 19, sir. You are number 20. You are 21. You are 22. 23, 24, 25, 26. You are 27. You are 28, my friend. 29. You are 30 on this laptop. 31. You are 32. 33, 34, 35, 36. Oh, you want to be connected to this network, no? Yeah, you want to be connected to that network. Okay, hang on. Can you put the, Nicholas, can you put the wireless password up? Yeah, put that in. Okay, you are 37. You are 38. Okay. You are 39. You are 40. You are 41 over here. You are 42. You are 43. You are 44, please. You guys, you are 45. You guys are 46. 47, 48, 49, 50. You are 1. You are 2. You are 3. You are 4. You are 5. Girls, you are 6. You are 7, my friend. You are 8. You are 9. You are 10. Again, don't forget your number. You are 10. You are 11. You are 12, sir. You are 13, my friend. You are 14, 15. You will be you participating? You will be 16, 17, Jerry. You will be 18. You will be 19. You will be 20. All right, we're just getting 1 or 2 laptops set up, and then we're going to click on our number. Okay, you are 21. 21. Yeah, put that in the top, in this tab over here. In this tab. Click it again. Hit return. Ah, CaribNOG-R, not R-E.
Oh, you're doing your own. It's even better. Okay, thanks.
Yep. Are you guys didn't get numbers? Oh, sorry. You can be number 49. You can be number 50. Sorry. CaribNOG-R.telabs.training. And you're connected to in the Wi-Fi. Okay. In another tab, can you just go to Google? Yeah, see, it's working. The search is working. Hey, Nicholas. Come here. Okay, go back to the other tab, please. His DNS is clearly working. Is there a typo there I can't see? Try and put the www in front. Do we have to append it with HTTPS? Put HTTPS in front of it. Oh, there we go. Okay.
There should be a mistake in the typing that we didn't see. Yeah.
CaribNOG. NOG. And then capital C. ARIB. Capital N. Capital O. Capital G. 2023 dash 02. Great. You remember your number? 28. Okay. Okay, we're ready to move on. Please click on your number where it says connect. Thank you again for your patience. Okay. They're all there. Switch?
Yeah, I will switch and
Yep.
explain the. Okay, so I'm going to ask once again. Everybody should be seeing this. Okay, everybody should be seeing this screen or already click on its own group as David just mentioned. So you should be seeing something like, let me go there, something like this, okay? Should be seeing something like this, which will be your network for the rest of the day, okay? Just make sure that up there in the corner, it says group and your group number. I'm going to be group number 55, but you have a group number, so make sure the number that shows in your screen corresponds to your own group, okay? Good. As you've seen, when you click on the previous screen, when you click on your group to connect, it will pop up another tab, so you can always go to the previous one if you have to, okay? So now, just leave this open for the rest of the day, and go back to the previous tab, you will see a link up there that it says BGP and Secure Routing Lab Script. Open. Just press open. It will pop up another tab with the lab script on it. This is the script we'll be going through today along all the lab, okay? This is the stuff we'll be doing today. Just let's go to the top of it. So you should be seeing something like this. If you go down, you will have the same network architecture that you are seeing in your group tab, and then the lab description. We are going to go step by step through all this script, okay? Good. Yeah. So, the first thing we are going to do is go back to the tab when you have your network. You'll see that we have some stuff there. We are going to fast comment what's here, okay? Don't worry if you do not understand some stuff here. We are going to go through all the necessary knowledge you need to know about this and to learn about this. This is the network you are going to use, okay? This device here, in yellow, it's called router, okay? We will see later what a router is, how it works, what's for, why we need it. But this is a router. This symbol, it's a router, okay? And this device here that says CIL, sorry, it's a client. It's a device. It could be any device. It could be a phone, it could be a laptop, it could be a fridge, it could be a light bulb, as long as it's connected to the internet, okay? Any device, that represents any device connecting to the internet. In this case, in the case of the lab, this will be like a machine with a operating system called Linux running, and we are going to be using that as a client. We'll be going to be sending commands, issuing commands on that machine to see some stuff during the lab, okay? So you will have access to the client and to the router. What I want you to do now is place your mouse over the router and just click on it.
Real quick, for the participants online, feel free to click any group number that you want. You can pick 26 and 27.
Okay. As soon as you click on that, another tab will pop up. So the network architecture tab, it's going to remain open. You can go back whenever you need to. Now, you just log into the router. For some of you, this may be the first time in your life that you're logging into a router. What we normally do when you work at an internet service provider, you normally use command line interface, what we normally call command line interface. We are probably used to deal with this equipment with graphical interfaces, like when you configure your home router, you go to a web page, you have all the router options, and you click on them. This is not what you normally use when you're working in an ISP. You use the command line, because to use the command line, it's often far much more powerful than to use a graphical interface. You now will have this is 100% control of the router. You can do anything now with the router. So again, to all of you willing to find out what happens if I just issue this, please do not do that. At least not during the lab. At the end of the lab, you are allowed to destroy everything if you want. You are allowed to send any command, not till the end of the day, okay? Just content yourself from doing anything out of the steps, okay? So, we are in the router. When you're using the command line in a router, we send commands and we get answers from those commands, right? So, we are going to send the first command ever in the router. And the first command ever in the router we are going to issue it's going to pop up, it's going to show you in the screen the whole router configuration, okay? So the command you have to write and press enter is show space run.
One second. Hey, Nicholas, over here.
Yeah.
We have some participants that are actually getting permission denied. Do you want to walk through that? Resetting the password. We talked about it last night.
They are getting permission denied where?
Right when they log in.
Let me just wait there, everybody. Do not press anything else. Yeah, don't worry. It just you click on the client. You should be on the router. So go to the network architecture tab.
Go to your group tab.
The group tab.
Click on the router.
Click on the router. That's it. Okay. Just for you, because they are sharing it from, and one is locked and the other cannot. You know. But anyway, it doesn't make any difference. Okay. Again, the first ever command you're going to send is show run. So you write show run and just press enter. So the configuration will show and the screen will move fastly forward. You can, using your mouse, you can go back. So let's go back. Let's go up in the configuration. With the 2 fingers. Yeah, you just move with the 2 fingers. Okay. 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 So you can using your normally using you know this better than me, but normally using both fingers at the same time you can slide the screen up and down. Okay. So you can see the configuration there. I will let David take it from here and yeah.
Okay, so you're looking at your router configuration now, and it's, for many of you, it's just a bunch of gobbledygook, and that's okay. Does anybody here see an IP address in your router configuration? Yes, okay, I saw you raise your hand. Call out, tell me one of the IP addresses you see, please. Any one of them's fine.
Anyone?
Anyone? Just call it out.
100.64.1.30/22.
Excellent. That is called an IP address. And an IP address is super important here. When I'm here in Grenada. My wife is back in the United States. And if I want to send her a beautiful postcard of the beautiful beach, I have to put it in the mail. So to put it in the mail, I write it to Miss Liz at my address. And that letter goes, and it goes through the Postal Service, and it works its way all the way up to Washington, D.C., where it comes to my doorstep in my home. And then she receives a piece of mail addressed to her. That IP address is the address, just like I wrote Miss Liz at the following on Quiet Walk Terrace in Virginia. That IP address is the address for the router. So when you are going to YouTube, YouTube has an IP address. Your device, your phone has an IP address. And the only way the packets get to and from YouTube is using the IP address to say where it's supposed to go. The IP, my name is David. If you want my attention, you go, hey, David. And I say, yeah, what's up? Because you addressed me. You addressed me by my name. The IP address is the address of your router or of your device. And devices on the internet use the IP addresses. Now, my friend read off 100.64.1.55, and then it has a mask, /22. We're just looking at the 164.1.55. That's an IP address. Can I have the PowerPoint real quick, please, Nicholas? That's called an IP version 4 address. And what happened is when we built the internet in the 1970s and the 1980s, we used IP addresses for the machines, but we only built a system with 4 billion IP addresses. Now that's a bit of a problem, right? Because there's more than 4 billion people in the world, and there's way more than 4 billion devices in the world. So we ran out of IP addresses. So we not only have IPv4 addresses, we have the other address you see on your screen. If you look on your screen underneath that, you see letters and numbers separated by colons. And those are called IPv6 addresses. Here we go. Thank you. So this system here has 4 billion addresses. We need more, so we created a new one. And these digits go from 0 to 9 and A through F. It's hexadecimal. There are 8 quartets. There are 64 numbers, which is, crazy. That's 1.3 times 10 to the 37th. 1.3 with 37 zeros. 1.3 undecillion. It's a high number. It's an unimaginable number. But this is how we scale. This is how we add millions and billions and trillions and quadrillions of devices using V6 addresses. But they both do the same thing, okay? There's no difference between the two of these, except they have a different format, just a different representation format. They do the same thing. They are the address. They are David in Washington, D.C. That's all they are. All right, so we're going to start configuring something. We're going to start configuring the router to talk with other routers. But we need to introduce you to some terms in order to do that. So my friend Aaron will be with us in just a moment. Aaron is a network engineer. He works at Akamai. Akamai is one of these companies that delivers all of the content that you use and you don't even know it. I'm an adult. I have a credit card. When I have to pay my credit card, I go to my credit card website and pay the card. The credit card website's actually at Akamai. When I go to Microsoft.com to go download my Windows updates, the Windows updates aren't at Microsoft. The Windows updates are at Akamai. It's a gigantic worldwide network, and this guy builds it. And this guy runs it. And he's laughing at me. You're building an ISP today, just like Akamai. So I want you to understand a little bit about what you're going to be building. Now, Aaron's going to talk for a little bit, and he's going to show you a lot of terms. And it's totally okay if you don't understand the terms. But Aaron's going to have a broader message that you're going to apply in the next step. Go ahead, my friend.
Hey, everyone. Good morning. So thank you all for being here today. I am humble and pleasure to be here in Grenada talking to you all. When we talk about networks in general, one of the first things, if you're to take a computer networking engineering class, they're going to start with the OSI model. It's kind of this schema, an abstract of how, when you type in www.google.com into your web browser, how does it all come together? Well, first, it's actually better to separate these into separate layers. So each layer communicates and interacts to the layer above and makes use of the services of the layer below to do its job. Of course, unless the layer does not have layers below or above, such as like 1 or 7. As I go through this slide deck, we're going to be separating each of these layers and going a little bit more in depth, at least through 1 through 3, which are primarily just the layers that you need to understand to set up an ISP network. By a show of hands, I'm just curious, who actually roughly understands or has heard of an IP address before David gave the summary? That's awesome. All right, so the first layer is physical. We're talking wires and cables. The point of this is when you have what is commonly referred to as a Ethernet cable at home, on the inside it's just pieces of twisted copper or copper twisted together. The point is that computers, really at the end of the day, they're transmitting data in ones and zeros or zeros and ones. Somehow we have to get instructions or requests from computer A to computer B. And the way that we need to do this is over some sort of physical medium. So believe it or not, there's a common misconception of in terms of using a cell phone, even a computer, how frequently satellites are used. Turns out most of the world is interconnected by cable that is trenched in the ground or going over telephone poles. And then, check one, okay. And then believe it or not, actually there are tens, hundreds of subsea cables that interconnect all of our continents, transmitting all this data going from the United States to Grenada to Europe to Africa to Australia. So the point is, for the layer 1, the physical layer, we need to move a stream of bits, ones and zeros, from one end to the other by some medium, like copper, fiber, radio waves, and then convert them back to ones and zeros on the other end. So, like I said, the physical layer can consist of connectors, cable and fiber types, wavelengths of light, transmission rate. The cables that you most likely have at your home are copper, what is, again, commonly referred to as Ethernet cables, even though that's not technically accurate. But most of ISPs and like critical infrastructure is actually interconnected with fiber cable. Fiber cable is literally either a strand of glass or silicone that is encased in some sort of cladding or casing, and we literally beam light through it and use light as a method of communicating. Similarly with copper cable, putting electrons on that copper cable, what we're doing is basically pulsing through that cable. We're putting ones and zeros by saying 1 is a pulse of light, or like a flash of light. Imagine a flashlight, literally. You turn it on, that's a 1. Turn it off, that's a 0. And computers on each end of that cable are constantly checking very quickly, like at the nanosecond, picosecond, at a certain rate for effectively, do I see a 1 or do I see a 0? If I see light, or if I see electricity effectively on one end or the other, that's a 1. If I don't, it's a 0. And then as I was actually talking through subsea cables that go through the oceans, light travels, light is the fastest thing that we know in the universe, 3 times 10 to the 8th. It's the fastest thing that we know. However, just like a flashlight, if you were to beam it right here from where I'm standing to the end of this room, it may not actually make it all the way. That light will effectively have a certain amount of power that can only go a certain distance. After so much time, we actually need to re-amplify that light. We need to be able to make sure that it can get all the way from United States to Grenada, or Grenada to Europe, or Grenada to South America. So we have repeaters and amplifiers actually in the ocean that will take the original signal and then charge it back up again and shoot it back out. SFP in optics, this is again used in fiber, well, technically SFP stands for small form pluggable. On routers that we have in data centers, they basically just have a bunch of ports or slots that you can plug in these modules, or SFPs, that can either be connections over copper or fiber. There are others in just regards to fiber referred to as optics. So the next layer, the data link. We need to somehow organize or structure these ones and zeros in some manner. So we refer to that at the layer 2 as frames. The layer 2 has a variety of protocols that you can use, but for our application today, we're going to be using Ethernet. So remember that cable that I was talking about that we call at home an Ethernet cable? It's more appropriately called a Cat5 cable, but the protocol that runs over it is Ethernet, and that's why we commonly refer to it as an Ethernet cable. So Ethernet is structured in a way of containing addresses. Again, similar to an IP address, which I'll get to in about a few minutes here. Just below the layer of IP addressing are MAC addresses. These are actually how machines speak to each other. So a MAC address, simply put, is a globally unique address. So the IEEE is an organization that actually creates and distributes MAC addresses to hardware vendors, given that every machine literally on the internet has a globally unique address. So that Ethernet port in your laptop or your Chromebook, or even just the Wi-Fi card on your phone, has a unique MAC address. And so Ethernet is communicating machines are communicating with Ethernet using MAC addresses, using source and destination for this purpose. And we connect machines using switches. And this is commonly referred to, when you have a network of machines connected to a switch, as a LAN, a local area network. And how do they operate? In order to interconnect devices within a network, we use a switch, and we basically plug all the devices within that network to a switch, and it could be one or more if needed. So far, does that all make sense? Anybody have any questions? Fantastic. Don't hesitate, please. Don't be shy. So the third layer, building up a stack. So we've now built our network at home, right? Let's say, imagine your home, you have your phones, a laptop, a desktop, a TV, an Xbox, a PlayStation. They're all connecting to your home network at the layer 2. Now we need to somehow communicate from your phone to www.google.com, right? We need to now leave the house. We need to leave the local area network, and we need to reach something that's somewhere else. So this is where layer 3 comes into play. So we combine multiple layer 2 networks together such that data can flow from network A to B. This could be from, house A to house B. It could be from house A to some data center in downtown St. George. And when we're referring to layer 3 or these networks that span outside of a switch, we're referring to them as WANs, or wide area networks. So for this, you need another layer of addressing, because all the machines in your house are going to be speaking over MAC addresses. But in order to speak to machines that are outside of your local area network, you need IP addresses. So David already gave an initial introduction to IP addressing. Just a quick recap. So each layer 3 network needs its own group of IP addresses. So like all of the computers at your home have their own IP address associated to them. Or at least hopefully they do. So this group is commonly referred to as an IP prefix. The prefix is essentially just a group of IP addresses. And that's kind of the format that you'll generally see it. So each host in this layer 3 network has its own IP address. And that IP address is effectively configured on an interface. So that could be literally like the port that you plug in the Ethernet cable or the Cat5 cable into. Or it could be like the address that's configured to the Wi-Fi card on the motherboard of your phone. So the end of that IP address, right, you see the 192.168.1.0 or 1.1 later in the 2 bullet points down, has this /24 at the end of it. That's called a prefix length, and that denotes the size of the network, which is to say whether or not we need to send this packet inside of our house or outside of our house. My phone trying to reach my TV for remote control would be over a LAN, and my phone trying to reach a website like Google would be over a WAN. The longer the prefix length, the smaller the network, and vice versa. So that's possibly a little confusing. So /24 has 254 addresses in it. If you go further down to like a /31, that only has 2 addresses in it. If you go higher up to like a /8, that has a lot of addresses in it, in that group, or that prefix. So continuing on with layer 3. So routers use IP routes to find which interface or port to send the packet out of. So we already talked about switches. Now again, going up a layer, we're going to be talking about routers. So the machines talk to each other over MAC addresses. Routers use IP routes to find... Check. Okay. We may have several paths from a router to reach a destination. So links on one router in which the destination is reachable. For an example of this, there may be more than one option for a plane to take from Grenada to reach the USA. These routes can be statically or dynamically in the table. The route that is selected to reach the destination is done by a decision-making process. So, like I said, if there's 3 flights from Grenada to the United States every day, and effectively your destination is just the United States, you have 3 different options to get there. The routers effectively have a decision-making process built in that will effectively select one of those as best. So you can set permanent decisions. You can actually configure the router by hand to say, I always want to, if I'm ever going to go to the United States for whatever communication, I always want to take the route from Grenada to Miami. I never want to take the route from Grenada to Charlotte, because that's just a longer path. And my goal is to get to the United States and not any further. So shortest path first wins. Or you can let predefined standards and events in your network automatically influence which routes are preferred. In this case, Imagine you go to the airport and they say, you want to get to the United States. You have an option of 3 different flights. However, possibly the first flight that you selected now has some sort of mechanical error. You can't take that plane anymore. So in this case, the router will automatically detect that, say that, okay, that plane's not usable anymore. So now I have to take the flight to Charlotte. And then if that flight is not available anymore, maybe the last one is only New York, and I have to get to the United States, so that's the only option. So, and then likewise, like if a plane was down for maintenance, but now is flyable again, now we can take that path again. So that's dynamic control or automatic routing, for lack of a better term. Check. All right. Based on, for dynamic routing, here are some of the influences that could be at play. Link state, user influence distance, performance, monetary cost, and maintenance. So like link state, like I said, like is the plane usable or not? Is the link up? User influence distance. So like from one end of the cable to the other, how many miles or kilometers is that? That can actually be equated into a metric into the router configuration to say, link A is 50 kilometers, right, in distance, and link B is 75, and link C is 100. We can effectively, configure our routers to say that link A, given that it's the shortest distance from point A to B, that is the best preferred link. Because as I was mentioning earlier, most of the internet is actually connected over fiber optic. So light is the fastest thing that we know in the universe. Effectively, in order to speed up communication, the only way by doing that then is by shortening the distance, right? From point A to point B, if light is never going to change its speed, imagine driving a car at 60 kilometers an hour and you need to get from point A to point B. The only way to speed up that ride is if the distance is simply shorter. Performance. The path that you could take could possibly be lossy, as we say. There could be some sort of damage on the cable where every one out of every 100 requests could possibly just get lost because there was some sort of cut that happened. And if this cable is effectively continuously losing data or communication, it's impairing performance. You type in google.com into your browser, or you try to pull up a video on Netflix, and you're just waiting there at a loading screen. It could be that the request went out, but then some midway through that request, there was a cable cut, and poof, that request is gone. Now your browser's going to have to retry again, and we all hate lag or latency, right? We just want the page to load at the snap of our fingers. Monetary cost. Some links are literally, you have to pay for them to use and are more expensive effectively than. Otherwise, you could have links that are simply less monetary cost, or it could be even free or settlement free to use. And then last but not maintenance, which I kind of already covered with the plane example. So in terms of interconnecting networks at layer 3, we divide them into autonomous systems. And each autonomous system gets its own number. Effectively, you have an ASN. So just want to try this. Yeah, okay. An autonomous system is a group of networks administered by the same entity. An entity can be a school, an ISP, a wireless carrier, a bank, etc. There are around 4.29 billion different numbers available to assign to different networks around the world. So we have plenty of them. Think of AS numbers as a way to identify entities. Google is part of AS 15169. ICANN.org, where David works, and Nicholas is part of AS 40528. Flow has an ASN, and so does University of St. George. Sorry, we didn't actually label those on the slide, but they do have their own ASNs if they have their own layer 3 network, most likely. Most likely. And then AS numbers, as I said at the beginning, are used in routing processes to find the network's IP addresses are in. So each network is going to have their own autonomous system, and they're going to have their own IP addresses that belong to that network. So here's a visualization of what I was describing. So, yeah. Sorry about that. So anyway, so here are 3 different networks, right? AS1, 2, and 3. And if you notice, there's this acronym that's being used, BGP. Down here it's iBGP, and here it's eBGP. Inside your own network, you're going to be using BGP. It stands for Border Gateway Protocol. When you're connecting one network to another, that's eBGP, Exterior Border Gateway Protocol. So talking a little bit more about BGP. So we already talked about static and dynamic routes. For dynamic routes, detecting effectively what's happening in real time or as close to it, we need a way or a means for a router to tell its friends, we call them neighbors in BGP, or a peer, networks they connect to. This must happen automatically so that if a new network appears, disappears, changes, all neighbors will learn about that change almost instantly. And that automatic mechanism is called a routing protocol. So far, you all with me? All right. So we need to choose a routing protocol. We're going to be choosing BGP. In the case of interconnecting different ASNs, the protocol designed and standardized for this is BGP, Border Gateway Protocol. It's used to exchange those IP prefixes or those IP groups between different autonomous system numbers or different networks. So now you're like, all right, here are some fundamentals of how computers communicate to each other, but the internet, it's kind of this abstract thing. You hear about the cloud, I'm talking about BGP, but how do these networks actually interconnect to each other? Well, in terms of physical presence that they have in data centers, right, in Grenada and other countries, these big warehouses that just effectively are holding and powering hundreds of thousands of machines and network devices like switches and routers. We have different means of connecting different networks. So the first is an internet exchange. The internet exchange is generally used as a low-cost model to interconnect networks. This is usually some sort of community-driven project or possibly even private entity for commercial purposes that is saying, all right, in Grenada, we have, let's say, 25 or 50 different networks that we want to interconnect. And it turns out that most of them are all in the same building, right? So instead of network A connecting to network B, C, D, and E independently over its own private links, we can actually connect them all to a switch. We can connect every single one of those networks in the same data center to a switch, and then they can just simply communicate over that switch. That's called an internet exchange. A PNI or an SFI, that stands for Private Network Interconnect or Settlement-Free Interconnect. So, sorry, apologies for stepping ahead. Internet exchanges generally will have a per port cost, possibly even a monthly membership cost, but again, it's usually the lowest cost model for most networks. So the next kind of step up in terms of possibly monetary costs or interconnecting different networks is PNIs or SFIs, Private Network Interconnect or Settlement-Free Interconnect. So the point of these is possibly there is not an internet exchange that both network A and B participate in, or possibly they're in different data centers, possibly for whatever other reasons they want to actually, for most likely additional capacity, additional bandwidth, they will say, you know what, it's actually better instead of us connecting over the internet exchange to directly connect to each other. Run our own cable literally from my router to your router in the data center. So this is done over a PNI. Most of the time when PNIs are used, both network A and B agree that it is beneficial to interconnect our networks. And so with this said, it could be settlement free or effectively no cost to say, you know, network B is not charging network A to connect, and network A is not charging network B to connect. There is possibly some cost included for the actual physical cables that need to be interconnected between network A and B in the data center. That's commonly referred to as a cross connect. But besides that, there is no reoccurring cost for those most of the time. All right, so then the next step up, the most expensive, is IP transit, right? So in terms of how the internet is connected all together, we have this visual from the OPTI project, opti.org. And what what OPTI has done is given you a really cool visual in terms of how all these different networks are interconnecting to each other. And so that is zoomed out all the way. But if you go to opti.org, not today, but later, because just want to keep the labs in the same state. You can zoom in further and see that from all these different parts of the world, Asia Pacific, the Caribbean, North America, and Africa, and so forth, how all these different networks, that is literally like a picture of what the internet looks like, if you were to give it in a visual representation. So network A and network B can connect to each other over an internet exchange or a PNI if relatively they're in the same data center or in data centers adjacent to each other. But if I want to connect over long distances, we use what we commonly refer to as IP transit. It's also known as DIA, which stands for direct internet access. This is something that you have to pay for, or 99.99999% of the time, unless under special purposes, you have to pay for. So every bit, every 1 and 0 going over that cable to transit and from transit is going to cost you money. So the idea is the more you peer directly with networks, the less you will need to use your transit connection, and then effectively the less money you spend. Additionally, in terms of autonomous system numbers, so what transit networks have done is they have just spent so much money or capital to connect all of the major networks of the world such that they don't actually have to pay for transit themselves. They literally are connecting in terms of a hierarchy to the most interconnected networks such that they don't have to pay anybody else, but on the other way, somebody has to pay them because they have all these connections. So far, are you with me? Cool. Yeah. All right. Thank you very much.
Okay, let's go back to our laptops. You should be at the command screen. You should be looking at the interface. If you are not, let me know right now. Okay. Nicholas put it on the screen so we can follow along. Now look at this. Remember, you can use 2 fingers and you can scroll if you need to. What you have are your Ethernet. Oh yeah, what do you got? Yes, okay. Close that window. Close that tab. Yes, it's okay. Click on the router again. It just timed out. It's all good. Now type show space run. Wonderful. Thank you, my friend. Okay, so you have these interfaces. And look what they are. Look what you just learned. He's even more difficult than that in real life. This is ETH0. You see it on your screen? That's ETH0. Look at the description. What does it say? This is ETH1. It's the LAN. This is ETH2. It's the interface. This is ETH3. It's the DMZ. You see it in your router config right on your screen right now. There's an extra one, ETH4. It's not connected. This is it. Here's your router. Here are all the different Ethernet connections that your interfaces see. Okay, on one of your tabs that you have open, it says Labs, ISP/BGP. Click on it. This is a whole set of instructions, written instructions. I want you to click on Labs. It's our script. This is our script of all the things we're following along. I want you to please find the text that says verifying the initial configuration of the edge routers of the group. It's not too far from the top, but click on that tab, start at the very top of the screen, and scroll down until you see verifying the initial configuration of the edge routers of the groups. And you'll see the first command is actually the one we've already done. It's show run. But I want everybody to get there. I'm going to wait just another minute. Because what we're going to do now is we're going to enter our next command. But our next command is super, super long. So we're going to copy and paste. All right, good. You're there. Where are you at, my friend? You're lost. You're in St. Lucia, man. What are you doing? Okay, so here you want to scroll down. You're here on this page here. Scroll down. Yep, keep going. Keep going all the way until you get right there. Nope, one more section, sorry. Good, he made it on. He's back from St. Lucia. I hope you had a good vacation. Okay, everybody good? All right, now we're going to scroll down together We already did show run, and we're already looking at that configuration. Now I want you to scroll down, follow along with Nicholas who's scrolling. Keep scrolling down until you get to here. Go ahead and stop. Where it says we then add some route maps and access lists. Okay? I want you to be able to see these commands here, the IP prefix list, deny all, permit all. Everybody to get there? All right. Nicholas, you're up.
Okay. Okay. So everybody, is anyone not able to get to this point? Just raise your hand and we will send some help. Okay? So Aaron earlier talked about routes. Yeah? Those prefixes, those things we call prefixes that are groups of IPs that we assign to each network. So each network will have a group of IP addresses, IPv4, IPv6, assigned to it, okay? Now think about the whole internet. There are thousands of millions of networks that all together are what we call the internet, okay? So there are literally thousands of millions or billions of IP addresses that, let's say, live on that network. On that bit network we call the internet, right? If we go back to the tab when we have the network map, yeah, you'll see that this is your router, the router you have full control of, and there's another router here that says to internet. And that's another router here that says, it's called iBorder RTR router. That's a border router, okay? That router up there, it's receiving from an internet service provider in the internet. It's really, that's not a fake router. That's something that is for real, the same as your routers. Your routers are real routers. This is not a simulation. That's a real router connected to the real internet, by the way. That router there, up there, has all the routes, all the IPs, all the IP groups that live in the internet. That's about 1 million routes for IPv4. So that's about 1 million IPv4 routes plus 400,000 IPv6 group of IPs, okay? So it's 1.5 million routes. They are all learned by that router. What you're going to do now is you are going to bring up a BGP session that is going to build up a connection between your router and that border router. So your router, is going to start getting all those routes. But just don't worry, because we don't want each of your routers to get the whole 1.5 million routes, because you are about 150 here. There are 50 of these routers running. Each of you is controlling one of those 50 routers. If we send all the routes from the border router to each of your routers, that will be a lot of routes living in our lab. That will basically blow up the lab, and we are done. So what we have to do is, we will, before bringing up that connection, we will tell our router not to get all the routes, but only a small part of them, okay? How we do that? We configure something that is called access list, and or something that is called route map. What are access lists or route map? Access lists and route maps are basically filters. It will tell the router, you're going to receive a whole stack of information, just use this. a small piece of that, not the 1.5 million, but only a few of them. Okay? So the first thing, the next command or commands we are going to send to the router, it's we are going to configure that filter. Okay? So what I want you to do is place the pointer and the cursor on the first line there and select all, go down, select all of that up to this point, okay? So I'm going to do that here also, so you can see it in the screen, okay? So you cannot see it in the screen because of that screen, but it's David already selected all of that. So select all the text as it is and copy it to the how you call to the clipboard, okay? So that is to press you can either press Control C at the same time, you know about this, or the right mouse button, or with the 2 fingers on the mouse, and then select copy, okay? Then we are going to go to our router tab, yeah? But do not press past yet, because we are not in the configuration mode of the router. Now we are going to issue a command that will enable you to enter the configuration of the router. Okay? That command is configure terminal. So you put configure terminal and press enter. You see that the router prompt changes. Now it says config. So now take it easy, go step by step, think twice before doing, because everything that you're going to type from now on is going to change the router configuration instantly. Okay?
Just a reminder that actually these will auto-complete your commands. So you actually, for example, like it's pretty common just to type conf t when you're configuring routers, but if you see like, why is this missing an E? It's okay, the router understands what you're trying to do.
Yeah, thanks for that, Aaron.
Is everybody in config mode? Is there anyone not in config mode? We good? Okay.
Oh, there's someone that needs help. Okay, Aaron will go for providing help there, okay? So, once you are all in the configuration mode, you are going to right-click on the on your mouse pad or whatever and paste the configuration you have in the clipboard. Just paste. Okay? And press enter. Once you paste it, press enter once. Okay? You will end up with something exactly like this. Okay? So at this point, we have already a filter, all the filters configured in the router. The BGP connection is not yet there, so the filter is doing nothing. We just configure the filter. We are going to use the filter later, okay? So everybody is at this point? Does anyone need help to reach this point? Raise your hand. 1, 2, okay. There are two. So keep your hand up so we can go and provide help, okay? Just everybody, the rest of you that are there, just take some rest, wait a couple of minutes. We are going to help everybody to reach that point, and we'll continue from there, okay?
Space, T, hit enter. Okay, now go to this tab where it says labs. Yeah, and start copying that large block. Okay, so hit right click and paste, or just Control V. That's Alt. Control. No, okay, so it's not pasted. It's okay. Okay. 2 fingers, paste. 2 fingers. No, 1 finger now, paste. There you go. Hit enter one last time.
Anyone else needing help? Okay.
C-O-N, space T, configure terminal, hit enter. Now you're in config mode. Now use 2 fingers. Tap. Paste. There you go. And hit enter one last time for that last line. There you go.
So hey everyone, back in the day we actually had left and right buttons on our trackpads. On these Chromebooks that actually doesn't exist. For left clicking, it's 1 finger. For right clicking, it's 2 fingers at the same time. So if you're like, why can't I copy or paste? If you use 1 finger, that's left clicking, 2 fingers at the same time, that's right clicking to get to like a copy and paste option. And then just raise your hand if you need help. We'll get to you.
So yeah, it's if you click on 1 finger, it's left click, 2 fingers at the same time, right click, okay?
Feel free to raise your hand.
So any other one that needs some help? It's okay, just raise your hand and we will send help.
Also, guys, when you're pasting the config into the router, it may be that the very last configuration line is actually not completed. Just hit enter one more time until you see the empty space at the bottom, just like up here on the projector.
Everybody just do this. Just press enter twice, okay? I will do it here, like pump up, okay. Just to make sure that all the configuration is in place, okay? So we are set. All right, now we are going to exit the configuration mode. To exit the configuration mode, we use the command exit. So just don't hurry. Just right exit once, press enter. You're going to go 1 step up in the configuration. Just right exit again, press enter.
Okay, so everybody exit twice. Exit out of the route map, exit out of config.
If you accidentally type exit again, you will be thrown out of the router. Don't worry. If you're thrown out of the router, just close the router tab, go to the network diagram, press on the router, it will open again, okay? Because if you are not in the configuration mode and you issue the exit command, you exit the router, basically.
All right, is everybody exited and we're at the router prompt? We good? Okay, keep going.
Okay, so now we are going back to our lab script. Yeah, this is the last thing we copy pasted. It's the filter we were talking about. If you keep scrolling, you will see now we will configure the BGP session with the border router called iBorder RTR. Okay, now we will bring up the BGP session. So scroll down a little bit. You'll see the BGP configuration, and we have to do this carefully, very carefully. Now this is one of the places that we have to be very careful now. So I want you to go all together, step by step, okay? Because now we can screw all the router up. So take your time. Before pressing enter, just double check what's on the screen and then press enter. Do not hurry pressing enter, right? That's like driving a car and before looking at the front, just pressing the gas, you know, you're gonna hit a wall. So this is more or less the same. This is all the BGP configuration we're gonna do, but we are not going to copy paste that. No way. We are going to go line by line, at least the first 2 lines, okay? So the first thing I want you to do is, you see that there it says router BGP and a number, okay? That number, it's what Aaron told us about earlier, that it's called the autonomous system number. So the autonomous system number is the entity, the organization identifier. So each group, each of you will have a different identifier, okay? Because it's unique. It's only for you. Then it says 650XX. You will have to replace the XX with your group number. For example, if I'm group 1, my ASN will be 65001. If you are group 1, XX, you will change it for 01. If you are group 3, it will be 03. If you are group 31, it will be 65031. Okay? So it has to be 5 numbers. 6, 5, 0, and then the group number. Okay?
If you have forgotten your number, why did you forget your number? If you have forgotten your number, guess what? You can cheat. You have a tab on the right-hand side of your browser that says Group 55 Network, or it actually says what your number is. So if you've forgotten your number, look at your tab and it has your number.
Okay? So everybody knows which group number you are, okay? Now, I want you to copy that line. Just copy. Do not press enter until I say enter, okay? Just keep that in mind. Copy that line, and we'll go together. I will be doing this in the screen at the same time you're doing. So, I'm going to copy that line from here. I'm going to select the whole line, including both X. Copy, go to the router. Wait there. Do not pass it. Just wait there. Now we are going to enter the configuration mode again. How to enter the configuration mode? You can just write conf T. How do you say? Abbreviation of the configure terminal command, okay? So now it says your group number, RTR, and then config between brackets, okay? Now you're going to pass the command. Do not press enter, just pass the command. Okay? Both X are going to appear in your screen. Just delete both X and replace it with your group number. Remember, if you have a group number with only one digit, you are group 1 to 9, you have to add a 0 before that. So if you are group 7, you should add 07 instead of the double X. If you are group 25, just add the 25, okay? Once you have the command here, what is going to do? This command, what's going to do? This command is going to bring up the BGP configuration for your router using your autonomous system number, which is, in my case, 65055. Okay? So press enter. We press enter there, and you will see that the prompt changes again, and now it says config-router. Okay? We are configuring the BGP. So every command from now on is going to change how BGP protocol behaves in your router. Okay. Now, okay. That's okay? Can you hear me? Okay. Good. Thanks for that. I was about to eat the microphone. Thanks. I feel better now. Okay. So now we go back to the lab script again, and we have the second line. The second line says BGP router ID and an IP address. Okay, a number. Just again, copy all that. The second line, copy this line here, copy the BGP router ID, including the X, copy that line, go to the router, pass the line, and do not press enter. You have to, guess what? You have to delete the X and replace it with your group number. But now, just the group number. If you are group 6, just put 6. If you are group 24, just put 24. In my case, I'm group 55, so I just put 55, okay? You have to put your group number there again, okay? This command will tell the BGP protocol how the router will identify how this is the what we call router ID or router identifier. Is it the name, in this case it's a number, the number the router is going to have in the whole network. So this router, as for the BGP protocol, my router is going to be called 100.64.1.55. For group 2, it's going to be called 100.64.1.2. Okay? That's the name of your router in the BGP world. Okay? Let's enter. Okay? Is anyone still not there? Just raise your hand, keep it raised, and we will help. Okay? Just wait, everybody.
Everybody else good? All right, let's keep going.
Okay, just keep going. Good news. Now we can copy and paste a huge part of code. So be careful now, please. Don't hit the wall, okay? Let's go back to the lab script, and we have a lot of stuff here, okay? From line 3 on, we have a lot of stuff. I'm going to briefly explain what this is, okay? Before doing anything, I'm going to try to explain what is this. We already have the lane 1 configured in the router. That brings up the BGP protocol. We already configured the line 2, which assigns a name, in this case a number, to the router, to the protocol ID, okay? And then line 3 says BGP log neighbor changes, then no BGP default IPv4, blah, 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 unicast. We are not going to talk about that. That is going to take the whole year to explain. Don't worry about it. We need that. You learn from that in the future if you likely become or want to become a network engineer or network technician or whatever. But trust me, we need those lines. Then we have this neighbor and a series of IP addresses, and then a set of options that we are going to configure there. What is this block, and this block that says neighbor is going to do? Those 3 blocks are going to actually set up the BGP connections between your router and the border router in the diagram, okay? Actually, if you see here, it says address family IPv4, and there's another address family for IPv6. When we end up with this, you will end up not with 1 BGP connection, but 2. We will need 1 BGP connection to speak IPv4 language, and we will need another BGP connection to speak IPv6 language. Because guess what? Aaron already talked about that. IPv4 and IPv6 they have a very unhappy name, in my opinion, because it says IPv4 and v6. It sounds like there are different versions of the same protocol, right?
What happened to 5?
Yeah. So that's not true. Yeah, there are 2 different protocols, completely different and not compatible at all between them. So shame on the one that named it IPv4 and IPv6. They should be called IP1 and IP2, right? There are 2 different protocols. It's not 2 versions of the same protocol. It's 2 different protocols. They are not compatible. So we need 2 links, one to speak one language, the other to speak the other language, okay? So we will bring up 2 BGP sessions. This part will bring up the IPv4 part of the session, part of the protocol, and this one will bring up another BGP session between your router and the border router to speak IPv6. And if you see here we are using IPv6 addresses, and here we are using IPv4 addresses, because there are 2 different protocols, 2 different languages to speak, okay? So what I want you to do is just from line 3, from the line that says BGP log neighbor changes, including that line, from that line, copy all to the end. Copy everything there until the end, okay? Once you have it copied, go to the router and wait there. Okay? So now we are back in the router. We are in the router, and the router is in the configuration mode and into the BGP configuration mode because it says config-router between brackets, okay? Before pasting, I want you to issue another command, a new one. This is going to be a new command, and this is one of my favorite ones. So what we want to do right is do space show space BGP space summary. That's a long command. Do show BGP summary. Do not press enter. Do not move the car yet. Okay? Everybody's there? Now press enter. Oh.
Feel
Wait.
free to raise your hand. We'll come over.
So everybody is there. Press enter. You should see. Don't worry. This is good. Nothing wrong is happening. I'm going to explain this. Let's wait just a few seconds so everybody is in the same page. Okay. Okay. Just wait a minute. Okay, so several people are getting their first ever fine for high speed in the highway today. It's a joke, partially a joke. Because what happens is that you should be all getting this message. No BGP neighbors found in VRF default. You should all be seeing that. But there's some of you that couldn't resist pasting the configuration and already have the BGP session up and running. Shame on you. That goes also for those online. Maybe you, because there are some online. So please, from now on, do not press the gas until we have both hands and our side in the front of the car, please. Okay? Those of you that are doing things right, step by step, should be seeing this message. That is, there's no BGP session yet. Okay? But it can be that someone already configured the BGP session. Just wait a second. Yeah.
All right, so just to reiterate what Nicholas just said, fortunately we have so many participants, and we have a limited amount of routers. So we have some online participants. We actually have some people in this room that you're actually using the same group number. You're configuring possibly at the same time, and possibly you went a little bit ahead in the instructions. So when you're typing this command, do show BGP summary, and you don't see what you're seeing here on the projected screen, and you actually see BGP neighbors configured. Unfortunately, like I said, we're sharing here. Sharing is caring. So effectively, somebody went ahead in the instructions and already configured the neighbors. So just follow along as best you can.
Yeah, okay. So again, just to play the bad cop, do not step ahead. We are a team. We have to go all together. If you ever get to work in an ISP, in an internet service provider, and you are responsible for doing this in the ISP router, and you do this, you go ahead the rest of your team, you can screw things up. You can end up with millions of users out of the internet because you just typed a command that you should have wait for the rest. Okay? So, and again, this is a real router. This is not a simulation. You're configuring a real router. Okay? Only that if you screw things up, nobody's gonna get harmed. But that's the only difference. Okay? This is a real router and it's really connected to the internet. You'll see it. So, for those of you that got this message that says there's no BGP configured yet, just pass the configuration and press enter. I'm gonna do it in my computer here, okay? I'm gonna pass the configuration and press enter. Twice, 2 times, press 2 enters, okay?
So go back to the GitHub page, copy the rest of the configuration, and paste it just like Nicholas did.
Yeah. Anyone not being able to get to this point yet, just raise your hand, wait for help.
Don't be shy. And remember,
Okay, that's one there.
1 finger for left click, 2 at the same time for right click.
Just keep your hand up so we can see it, and okay, that's it. I assume that the rest are there. Just wait there. Do not go ahead of the team. Okay? You have to do this all together. Pretend you are learning to drive. We don't want to, crash our dad's car. So go step by step, okay? If not, dad or mom is going to get really pissed off. Okay, so now we are going to exit the configuration. To exit the configuration, and wait, do not type exit yet. I'm looking at you. Yeah, some of you started and wait. Right, exit, press enter, 1 step up, exit again, and we are out of the configuration mode of the router, okay? Now we are going to repeat a command we issued earlier, but we are going to repeat slightly different. We are going to repeat the command that shows the BGP configuration, but without the do at the beginning. So the command you are going to send now to the router is show BGP summary and press enter. And a lot of information will pop up. I'm going to briefly explain what's on the screen, okay? So, here it says, show BGP summary, right? And all of this information appears. If you look at it, it says, the first piece of information says, IPv4 unicast summary. That's the information for the IPv4 BGP session, okay? It says, router identifier, the name of the router you said some time ago, right? Earlier we assigned a number to our router that should be 100.64.1. Your group number, okay? Then it has a lot of information there, and if you look down here, you will see neighbor description 100.64.0.10. All of you should have this here, 164.0.10, okay? This is the IP address of the interface of the border router you are connected to. So this is your neighbor. This is the border router, your friend now. This means that something is going on between you and this other router. So what's going on? This is the autonomous system number of your neighbor. So your neighbor has the autonomous system number 65000. That's the autonomous system number for the border router. As we all set up a connection with the same border router, you all should see this same number in your screens. Then you have a couple numbers here, message received, amount of messages sent. Don't worry about that. That's the amount of messages. BGP is constantly, once you bring up BGP, it will constantly exchange information and messages with the border router. Even if it has nothing new to say, he will say, I'm alive. A couple of seconds later, like 30 seconds later, he will say, I'm alive. A couple of seconds later, I'm alive. If there's new information, it's going to say, I'm alive. This is the new information, okay? I have new friends. I'm alive. These are my new friends. Every 30 seconds, it will tell the other router that's alive. Why? Because if the connection falls, suppose that someone goes and unplugs the connection, the physical connection, the cable between your router and the border router. If that happens, the BGP connection will go down. The border router and your router will stop receiving the keep alives. The keep alives are those messages that says, I'm alive. If your router stop receiving those messages for a certain period of time, let's say 1.5 minutes, it will bring down the BGP session. So the BGP session will go down, okay? But this means that the BGP session is up and running, okay? Here it says up/down, and it's a time format number. That's how long this BGP session is being up and running. So if when you issue the command, when I issue the command in my router, it's been 2 minutes, 20 seconds, the BGP session was up and running. If we go back home, came back tomorrow, send the show BGP summary command again, and we look at this number will say something like 20 some hours and some seconds. That is going to count from 0 up to the time while the BGP session is up and running, okay? And lastly, we need to explain these two numbers here, okay? Here it says prefix received, and here it says prefix sent. What's the BGP session for? Why do we bring up a BGP session? Well, Aaron explained it earlier. The BGP session, the objective of having a BGP session up and running is to exchange network information between the routers. So the routers will tell each other which networks they have connected to, okay? So all the routers, after they pass on all the information, all the routers will know which networks are connected to which router. Why? Because all of those networks, we will see in some seconds, we know come from this entity, from this organization, the one that has the AS number 65000, okay? And this router within that ASN. So within that autonomous system number, there is a router that is called 164.0.10 that is sending us 37 networks. And we are sending back also 37 networks, okay? Because we also send all the networks that we have. We have no new networks. We are receiving 37, so we are telling the rest that we have 37, okay? Then, if we go down, we have the same We are going to go faster now. If we go down, we have another section that says IPv6 unicast summary here. You see? IPv6 unicast summary. This is the IPv6 BGP session. Same. Name of the router. Now it's an IPv6, not an IPv4. This router is called FD8855DE blah, 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 10.
Anybody stuck?
Are you all with us? Yeah? All together? Okay. No one is crashing the car elsewhere? Okay. Same autonomous system number, different name for the router. This is a name. This is a BGP session for IPv6, so the name now it's an IPv6. This is the ASN, the same. The time, because we bring both up at the same time, they have the same amount of time here. But for IPv6, we are not receiving 37 prefixes. We are just receiving 25 prefixes. And we are announcing the same amount of prefixes because we have no new networks connecting to our router, okay? So now we have two BGP sessions, one for IPv4, one for IPv6, and a couple of prefixes, networks, we are learning from the border router, okay? We will wait some seconds for the rest of you to come to the same page, and we will continue from there, okay? Any questions? No questions? If you have any question, if there's something that you would love to know about this, just ask. This is for you. David.
Okay, so Nicholas, it is 11:30. It's time to get some energy out. So if you're at this point and you're totally caught up, you can go ahead and take a break. We're going to come back here at 11:45. So everybody, you got a 15-minute break. You can get some water, get some coffee if no one catches you.
Just leave the Chromebooks or your personal notebooks, your personal belongings here. It won't happen anything. You can go out and leave everything here. Do not close the computers. Just, yeah.
I think you're
Please find your way to your seats. All right, everybody in the back, students in the back, please come on, find your seats.
Check.
Okay, as you start to find your seats, we are going to pivot for just a little bit. We're going to get away from setting up our router, and we're going to talk. Okay, we are ready to begin. If the folks in the back could hold your conversations a little quieter. Okay, everybody, thank you. So for the last few hours, we've been working on turning up our ISP and turning BGP on to get packets flowing. And you've gotten exposed to a lot of network engineering concepts and principles, and you've actually tried it out yourself. For some of you, this was really, really interesting. Like, you want to go play with this at home. For some of you, this was like, okay, that's kind of cool. I'm going to go back to painting now. Some of you are interested in maybe going to work at YouTube. Some of you are interested in becoming software developers. Some of you are interested in becoming a teacher or a principal or an administrator. And when you do that, you're also going to need your technical skills. So we want to stop for a few minutes, and I want my colleague Aaron, Mr. Aaron, he's going to talk a little bit about what it takes to build a career in ICT, what it takes to build a career in network engineering, what it takes to get a job at Google or at Microsoft, or what it takes to build your own company and the skills you're going to need because you're going to have to hire people who understand IT in addition to finance, in addition to law. So, without further ado, Mr. Aaron is going to talk for a little bit about careers. And when you have a question or when you want to say something, just raise your hand and let's have a conversation. Aaron.
Thanks, David. Hey, everybody. Welcome back. So, as Claire said earlier, we are all CaribNOG. Can I get everybody to say that? We are all CaribNOG? All right. And now after the introduction to our class earlier today, fair enough to say you are all network engineers. So can I hear that? We are all network engineers. Come on. All right. People some still coming in from the break. Let's get them all seated. So, thank you all for being here. Like I said, my name's Aaron Atach. Humbled to be here. Whoops. Who am I? What do I have any respect in doing to be here? So my name's Aaron Atach. I was born and raised in a small city in the Chicago area. I have a multicultural background. My mom's American. My dad is Turkish. Part of that was actually my inspiration of entering this field. My dad grew up in a pretty remote part of eastern Turkey, and schools were not as easily accessible, right? And growing up in the States, at least in the part that I live in, the idea of a school not being within reach is not common to find, or at least for the neighborhood that I was growing up in my area. And when I find out that actually several communities all around the world don't have an elementary school, don't have a high school, don't have a university even to attend, I want to help fix that problem somehow. And so that was really what initially sparked my desire to go into network engineering. So in general, the idea is that Granted, several communities throughout the world suffer various problems. If education is one of them, we still need teachers. We still need textbooks. We still need labs, instructions, homework, and so forth. But if there is no school for you, literally you to walk to or to take a bus to, the idea of giving you an internet connection just increases opportunity. And so I want to help fulfill that mission in any way that I can. Additionally, when my dad initially came to the States, he was working on a cruise line. As a bus waiter, worked his way up to, as a bus boy, worked his way up to head waiter. My mom was a travel agent, and that's how they met. When he actually, so they got married. And then when my dad came to live with my mom, he started to study computer science at a local junior college. And then at the same time, he was waiting tables at night. So, or vice versa. Anyway, I was inspired by Dad, not only from where he came from, but his interests at the time. And I wanted to basically just, replicate or follow my role model at the time. Turns out now he does insurance, so things have changed. Don't know what happened there. Give me 1 second. Hey, can we put the slides back? Pardon the interruption. AV booth, do we know why the slides aren't showing? As you can see, computers don't always work. AV booth, we need your help. I don't know why the slides aren't showing. They were there, and then they were gone. Thank you. All right, back on it. So that's how I got my interest in computers, and as well, network engineering. I wanted to be able to provide education to underserved communities as best as possible by facilitating an internet connection. So I was fortunate enough to grow up in an area where I did have schools within reach. One of them was offering a program, actually, an undergraduate degree, a Bachelor's of Science in Network Engineering and Security. 20 years ago, that didn't exist, so I was lucky. I graduated in 2018. So passionate about making the internet accessible, fast, reliable, and secure for everyone around the world. I'm also a music enthusiast, and I started DJing during the pandemic because I was bored, but also I always had an interest in doing that. That's Sister Bliss on the left there from Faithless. If you're familiar with the group, it's an electronic music duo that actually, one of the members, not Sister Bliss, but her co-part, Maxie Jazz, actually just passed away in December, so R.I.P. Maxie. Stand by. All right. Okay. I think it was an adapter. Back at it. So, my history as a student. I went to DePaul University. That's my school right there. That was our network engineering lab. It still exists today. Like I said, very fortunate, very lucky. We were able to do our homework effectively on the rack of switches and routers in this lab. I was a part of a group called Security Daemons, and that was a cybersecurity-focused student group. And we participated in a variety of cybersecurity competitions, which, just to highlight that point right now, in terms of extracurricular activities, any kind of activity, from this one to a hackathon, a cybersecurity competition. There are a variety online that I can talk more on one with you about. I encourage you to participate in. It is definitely a resume builder, gets you familiar with the technologies that you might be interested in pursuing a career for. And so one of the things that DePaul specifically was known for, and part of the reason for attending besides the program offering, was there's this competition that is a collegiate cyber defense competition in the United States, CCDC. And the idea of that is basically you have a group of students, 8 students, 6 undergrad, 2 grad. You walk into a room, you assume responsibility for infrastructure in that room, and you have to as well assume that all of that infrastructure has been compromised. At the same time, you'll have a red team that will be attacking that infrastructure, trying to bring services down. So one of them will be like an email server, the other one will be a web server, the other one will be a firewall. And this red team are like these hackers, these bad guys are trying to take it down. Every minute or so, the system checks if the service is up. If it is, you get a point. If it's not, you don't get a point. At the end of the game, whoever has the most points wins. So I was fortunate enough in my participation at DePaul, we made it to 4th in nationals, which at the time was the 2nd highest that we ever got. So very proud of that. So when I was at DePaul, my 3rd year, I was taking this class called Network Protocols. And the professor at the time was working during the day and teaching at night. He's been in the industry for a couple decades. He's a very smart person. And he told the class, hey, there's this conference coming to town. It's called NANOG. Stands for the North American Network Operators Group. If you are interested in network engineering, you should attend this conference. This conference happens 3 times a year across North America. It's very expensive, from the person that doesn't have a company affiliation, that is not a student, that is, I shouldn't say very expensive, but it's not cheap for students is really what I'm trying to say. So for the conference to come to town, right, what I'm talking about is airfare. Airfare is not cheap. Hotels aren't cheap. I'm a student, eating turkey sandwiches every day, spending as little as money as I can because I got a bunch of student debt. So the idea that this conference came to town, I didn't have to pay for airfare or hotel, and the student cost to attend was very, very low. It was a very fortunate opportunity for myself to get more in depth with the community of the industry. I had attended cybersecurity conferences throughout those for those first 3 years of university, but I never attended like a specifically network engineering or network operator conference. And so I attended NANOG 67. That was my first NOG attendance in June of 2016. So I guess I actually correct myself, I was on my 2nd year. Anyway, I was in love with attending that conference. The community, it was completely different than any of the cybersecurity conferences I had attended in the past. And I think the main reason for that is it really struck my interests to a core of what I was really passionate about, which was interconnecting the world. And the people that attend this conference, similarly to CaribNOG, are some of the smartest minds in the world. Imagine like all these people that are literally like making the internet work, get together 3 times a year, and you can like go and talk to them, and possibly even like let them know your name, and possibly exchange information. Before you know it, you could give them a business card. So that's actually what I did. So after I found out what a NOG was, and I became so interested in attending NANOG, I was focused on getting an internship. It was not only a requirement of my degree, but it kind of was understood as the status quo. I'm not sure for the students in this room, but at the time, my perspective was, if you wanted to get ahead, if you wanted to be at the top, you need to have experience before you graduate. So the only way by doing that is getting internships or odd jobs. And the internships, as I'll talk about in a bit, kind of are a stepping stone into possibly becoming a full-time employee for that company. So it's an easy transition. So I said, all right, for the last 2 years, I was on my third year. That's what it was. It was in October. I was starting my third year. And I was like, all right, the last 2 years I've been unsuccessful. I've tried talking to upperclassmen, seeing connections that they have. How can I get an internship? I was also kind of very targeted in that I was trying to find like some of the best companies to work for, and just like kind of this race mentality of trying to get to the top, which I'll also address a little later in the slides. And so I wasn't having much luck, so I went to NANOG 68. I had saved up some money. I was working some odd jobs in college, and I paid for the airfare and the hotel and the so forth to go to NANOG 68 on my own because I couldn't get a professor actually to come with me at the time. If so, as I talked about yesterday, NANOG does have an NCI program that helps students attend this conference along with scholarships, so just keep that in mind. The other thing that NANOG does is it publishes an attendee list. So you can literally not only attend the conference, but pull up a website and find out exactly who is there and what company they work for. So I took that list, I took all the companies in that list, and I trimmed it down to what companies out of this list would I be interested in working for? What were some of the companies that would possibly best benefit my career? So out of possibly like the 200-300 companies that were there, I trimmed it down to maybe 50. Out of that 50, I said, all right, out of all these companies, which one offer summer internships to university students? So simple Google search, trimmed it down to maybe 15 companies. Then while I was at the conference, just due to hunger and desire, I was fortunate enough to have enough courage to approach people, tell them who I was, and asking them, you know, even though I knew in the back of my mind, hey, does your company offer university internships during the summer to students? And turns out that worked, and it worked really well. And I got a stack of business cards that I came home with. So now I have these people, these smartest minds of the world, I have their email where instead of applying online to some job application, I can literally email these people my resume directly. That's huge. So that's what I did. And there's a slide missing or possibly out of order that we might find later, but basically what I was trying to say was, so I found this company called Akamai, or I met somebody from Akamai at the time. It's a global CDN. In short, the main point of what the company initially started to do in 1998 was create a CDN, a content distribution network. Imagine there's a popular website that you all want to visit, like CaribNOG.org, okay? And let's say it's a very popular website. Multiple people want to request and visit this website every single day. Imagine this website is hosted on one machine in the world in Grenada, here in St. George. That's a lot of traffic for that one machine. That's a lot of resilience that the machine needs to stay up and serve all those requests. And possibly the machine is very vulnerable to security threats. If anybody hacks that machine and takes it down, nobody can go to CaribNOG.org anymore. So what Akamai does is we copy that content to a bunch of machines all around the world. We call it a cache. And then when you are online browsing the internet, instead of you going to the original source of that web page, you're actually just going to a copy. The point of this is that not only can we bring the content a lot closer to you, but then we also make it more resilient. In case one machine goes down, no worries. There's other copies that we can automatically redirect you to. If there's any possible security issue of like a DDoS attack, somebody throwing a bunch of traffic to a machine such that nobody else can visit it, not an issue. We have other copies that we can redirect you to. So like I said, sorry I'm missing that slide, but that's who I currently work for. And that all started out of going to NANOG or going to a NOG like CaribNOG, meeting people, putting a foot forward, having the courage to say, hi, I'm passionate, I'm interested in working for you, you know, and getting their information to email them a resume. So what are the basics in terms of finding a job in general and possibly more specifically a career in tech or network engineering? As you all know, resume or a CV, or, you know, for the most part, it's like understood. The point is that you need to tell people who you are, right? What you're passionate about, where your experiences are, do you have education, what kind of education, and so forth. The tip that I have for you today is less is more. So I've been working for Akamai now for 6 years, 1 year as an intern, and then 5 years professionally. I'm actually now in a role where I interview people. And I can tell you, out of the resumes that I get, less is more. If I get a resume that's 3 pages long, double-sided, that's a lot of information. And possibly it's a little too much of telling me, like, you know, what you did at 10 years old, don't really need to know. So if you can draft that resume, write that resume in a way that is focused specifically for the job that you're applying to, that will help significantly. And then as well, we're looking for bullet points, because when you actually come and interview with us, we want to discuss. We want to get to know you. We want to know your story. We don't necessarily want to read it entirely off of a page. We just want to have a rough understanding of who you are and what's your background, and then we can take it from there in the interview process. So then it comes to job postings. So when you're browsing the internet, whether it be LinkedIn, Indeed.com, or possibly some local Grenada organization that, you know, advertises job that I'm not familiar with, and you're browsing these websites for these job opportunities, you're going to come across requirements within that job. You don't have to check all the boxes. Some of these job requirements will list 20 different requirements. And when somebody looks at that, possibly from a certain lens, they're thinking that I need to know every single thing to get this job that they are asking for. That's not true. Turns out that most job postings, they're giving requirements, calling them requirements, but all these different things that they're asking for, if you actually check every single one of those boxes, that is the perfect candidate. It turns out nobody's perfect. Nobody's going to check all those boxes. Excuse me. So don't be intimidated. If you see a job posting and you're interested in working for that company and you think that you can, you know, effectively learn and accomplish, then apply for the job is my recommendation. Certifications and degrees. They help, but real-world experience is second to none. Education is, of course, important. That is the #1 reason why I went into this field. But possibly, if you were not fortunate enough to get a specific education for a specific job, don't doubt yourself. I work with people every single day at Akamai and elsewhere that don't have a college degree. And they're literally some of the smartest people in the world. So these certifications, possibly offered by hardware vendors. If you're familiar, Cisco is pretty popular offering a networking engineering certification track. The most common one is CCNA. That's kind of like the base level, and then it works up from there. In a way, prior to network engineering degrees existing, some people viewed this as a way of getting you know, a resume builder to say, I know about network engineering and I can do network engineering things. It definitely aids you, but I was at DePaul for 3 years in a university program studying engineering. When I came to Akamai in June of 2017 to intern, I figured I had 3 years of experience of understanding like network engineering and the principles of switching and routing and so forth, and the internet and how it works. When I walked in that door, it was information overload. I was like, man, I know nothing, and I've spent 3 years already studying this. So that's okay, and it's expected. So just keep that in mind, that these certifications, these degrees, they help, but they are not necessarily always required, especially like big companies now. For example, Google, I know, doesn't require university degrees. You know, it possibly is preferred for certain positions, but I remember like just a few years ago they said, and along with a couple other of the big ones, they're like, we're not going to require these, right? We're not going to just filter you out simply because you don't have one. But education is important if you have the opportunity. Honing automation skills. So we're all configuring routers by hand today. Turns out 20 years ago, that's how everybody did it. Now, most networks, most big networks, most large enterprises, service providers, cloud companies, etc., they're not configuring routers by hand. They are writing software to manage configuration, IP address management, routing preferences, changing of paths and preference, you know, therein. So what I encourage you to do is, in terms of the future outlook, one of the first things that I can tell you is that automation is the future. And so the more that we can automate tasks, simply the more that we can reduce failures and execute work faster. Humans are imperfect. We are going to make mistakes. Even though humans write software, it turns out that the software generally makes less mistakes than humans typing into a keyboard. as you can see, as we already went through with Nicholas configuring these routers, if you type one key wrong, doesn't work, right? Or it may not. And the point is that if you're configuring routers by hand in a professional setting and you type configuration incorrectly and that changes how the device operates, you are going to possibly impair the service of the customers of your network. So the more that you can focus on software engineering skills, if you were to take one thing away from anything that I say today, I would say that's the number one thing, is that software engineering is the future, automation is the future. Last but not least, visas. So I put it on the slide because I know it is a concern if possibly, you know, the company that you want to work for doesn't have an office in country. Or possibly you want an opportunity elsewhere in the world for a variety of reasons. I was fortunate enough where, you know, I'm living in a country that I have the company that I'm interested in working for here. I don't need a visa elsewhere. So I don't know what that's like. So I'm just putting that out there of saying that I don't know what that is like. However, since the pandemic, remote work has become huge, right? Like nowadays, you don't have to fly and work out of New York or San Francisco, Silicon Valley, whatever, to work for a tech company. You can work from Grenada. So don't let that be a hindrance. Is actually the main reason why I put it on the slide of like, oh, I want to work for possibly a company that is headquartered elsewhere in the world, or even if the job posting is for a location that doesn't say remote, apply for it anyway. I'm not joking, I'm not kidding, seriously apply for it anyway, because again, those job postings are written for the perfect candidate and nobody's perfect. So hunger, the grind, the hustle, right? If you want any job, a job in career in tech, you have to be hungry for it. You have to have a passion. Because turns out you can apply for 200 companies and you're only going to hear back from 10. No matter how smart you are, it's just how it works. Out of that 10, you might get an interview with 5, and out of those 5, you might get an offer from 1. So rejection is going to happen, but don't let that stop you. Continue. Persistence pays off, which I'll mention in a second here. Stay hungry, right? Whether if it's for a job you want, a salary, a location, whatever, stay hungry. Have a long-term vision of, all right, you're starting your career. Where do you see yourself in 3 years, 5 years, 10, 20, right? Try and, like, you make a budget for, you know, groceries or how much you spend on Fortnite or whatever, right, out of your salary or job. Have a long-term vision of where you want to take your career and try and map that out such that you can make decisions earlier that can influence the future. The role or the smartest person in the room. So keep in mind that if you are the smartest person in the room, it's probably not the best company for you to work for. If you are literally looking for gaining more knowledge, right? So sometimes you could be working for a company, you've been there for X amount of years, possibly up to a decade or more, and you realize that you're hitting a plateau. It's leveling off. You're not really learning anything more. Generally, that means it's time to jump. It could mean that, you know, you're comfortable being in a teaching capacity or an educative capacity of saying, you know, I'm passionate about the company that I work for. I want to help that mission and as well new employees. So be it. But if you are the smartest person in the room, generally it means that, all right, it's time to go and look for something where you can continue learning more, gaining more skills. And that goes into job hopping. I don't have statistics on this slide for this. Apologies. But it turns out, you can Google this yourself, the more often that you change jobs, the more you will learn and the more money you will make. Full stop. It's just how it goes. So if you're waiting to work for a company and you're like, all right, you know, I just am getting my footing here in IT or tech, and I want to possibly work up the corporate ladder. I want to go from technician level 1 to 2 to 3. The advantage nowadays, if you're looking for the highest salary and learning the most, is actually hopping around jobs every 1 to 3 years. So just keep that in mind. And then diversity and inclusion. Women take up 28% of the tech workforce worldwide. Only 28%. And only 15% of women have engineering jobs or hold all of the engineering jobs worldwide. But 49.6% of the world population is women. We need more women in tech, just in terms of a specific sector of diversity and inclusion. But so I encourage all the women in that you are needed, you are welcomed, and we are trying to get more women in tech. There's that slide. Found it. All right, so a couple quotes that I just wanted to give you. First one, perfection is a lot of little things done right. That was by Marco Pierre White. If any of you know him, he's a famous chef. Or if you don't know him, he's a famous chef, Michelin star chef. He also trained Gordon Ramsay. If you know Gordon Ramsay, Hell's Kitchen, and so forth, that was Gordon Ramsay's boss. So that's a quote that I live by and I affiliate with or agree with. And then my first boss ever told me persistence pays off. I can't think of any truer statement. Right, and one that I resonate with and believe in. So I highly encourage, if you are facing rejection or any kind of anxiety or so forth or failure, persistence pays off every single time. You're troubleshooting a problem on a router and you're like, I can't figure this out. The feeling that you get when you eventually do, which you will with time, is priceless. So how do I find a job? Here are some sources: friends, alumni, classmates, LinkedIn, at least in the States, I know that that's huge. A career center out of your school, your community, and so forth. Conferences, CaribNOG, NANOG. Company website. Notice I put company website last. That was actually intentional. The point here is, when you apply for jobs on company websites, a lot of them nowadays have filters, software prepared for any resume that comes in. It's going to scan that resume for certain words that are or are not within that resume or that CV. And effectively, if you are not a match, nobody even looks at your resume. So the point is, and kind of the method I was telling you before with NANOG and talking with people and putting yourself out there and getting email addresses, getting that resume into their email inbox is actually going to get at least one person to look at your resume. Whereas a web filter on a company's website could possibly just immediately delete it. So I encourage, word of mouth, believe it or not, is how I find a lot of people in tech are getting jobs. It's who they know, getting a foot in the door, and developing a relationship with them to say, hey, I want to work for you, and I think I have the skills that you need. LinkedIn, I would say out of all the possible job websites, at least in the United States, because that's just what I know, is generally where you're going to find the highest quality jobs from my perspective. That's just my opinion. So, and then investigation. So I listed some, I'm going to give the slides to everybody here, so don't worry about that. But here are a few websites that you can basically learn a bit more of like the insides of a company. So the first one is Glassdoor.com. You can get pros and cons from that website about what it's like to work for a certain company. Of course, these are all user submitted, so if nobody submitted anything, you're not going to learn, but possibly there could be many, many reviews there. Also, salary information to find out, is this a company that I want to work for? Levels.fyi is a specific website targeted to careers in tech and salaries associated for certain levels of a company. Teamblind.com is a bit controversial, but effectively it's like anonymous people that work for certain companies discussing the insides and as well possibly salary information. And then Reddit. Feel like that needs no explanation. So internships, as I touched on earlier. The job is scoped to be an entry-level job or a role, right? So they know you are not really an expert in whatever you're looking to accomplish, and they are as well willing to train you. And a mentor is usually provided. So when I joined Akamai, at least in my experience, I was assigned a mentor. And that person not only was helping me with questions and answers, but also checking in with me personally. Like, how are you doing? How is this going for you? What are, work aside, like, let's go get lunch and just like talk about life. So keep that in mind. Skills will be tailored for the company role you're interning for in particular. This is meant to be a path to convert you generally into a full-time employee. So if you're looking to get into a company and you're just starting off in your career, you're not looking for high salary or high titles with, anyway, with like senior and principal in the name and so forth. The internship is the perfect way to get yourself in, get yourself educated while usually getting paid. So yeah, internships. That's key. So, caution. There are some road bumps that you're gonna hit. First one is imposter syndrome, or at least, again, all of this is my personal perspective. So, you know, like I said, I joined Akamai. I'm like, I have 3 years of experience of education, rather, of studying network engineering. And actually, prior to that, like, I was interested in computers from a very young age. I didn't put it on the slides, but I was repairing computers basically since 14 in a job capacity. So I'm like, you know, I have all this information collected, and I go and work for this company, or I get an internship for this company. I get an opportunity to work for them. And when I get in the door, I'm like, I feel like everybody knows more than me. I know nothing here, and I don't belong. I don't deserve this role. They're going to fire me. The second that they find out I'm a fraud, I'm out of here. Turns out almost everybody has those same thoughts, and they are not true. You were hired for a purpose. You are hired because you should be here. They understand whatever capacity of experience that you have, and they're willing to work with you on that and grow it. So keep in mind, a lot of people face imposter syndrome. Don't let that stop you. It is a fallacy. Race and pace. So I also had this problem of, all right, I'm a first-generation kid. My dad came from, you know, a underserved part of the world to have a better life for his children. And I had all this weight on my shoulders that I felt of, you know, I need to be a doctor, an engineer, a lawyer, make big money, and make it all worth it for him to go through all those struggles that he did and to get where I am today. So I was constantly feeling behind. I'll admit, still even a little bit today. And I was having this mental health problem of, you know, not just imposter syndrome, but saying with my classmates, I feel behind. With the people in my industry, I feel behind. It's common, right? And I encourage you to acknowledge that you're only in a race with yourself. If you are growing up with a classmate and you both go into the same industry and they hit a big company right away out of school and you don't, nobody cares, right? Effectively, it means nothing for yourself. Don't compare. It's not going to help, right? You're only in a race with yourself, and there is no race, essentially, right? You need to go at your own pace, whatever that may be. And if it's slower than others, if you don't necessarily gain the skills or work for the companies they do that you're interested for, that's okay. Of course, naturally, you're like, but I want it. The point here, at least that I was experiencing, was I need to stop comparing myself to other people and where they are at and just focus on myself. Last but not least, unfortunately, there are some toxic work environments. Commonly, in the tech industry, a person that is toxic is referred to as the technical jerk. So they're very smart, but they have no people skills. And possibly, they're literally mean to people. I hope none of you face that, but just be prepared for it. And if you face that in a work environment, let the appropriate people know, and possibly talk with yourself of saying, maybe I don't want to work here, because nobody deserves that. And I will say, as you know, the industry in time has progressed, technical jerks are less and less, simply just not accepted. You might know everything, you might be a huge resource technically, but you are just not the appropriate person to work on this team. All right, so in terms of an outlook of the industry of careers in tech, as I highlighted earlier, automation is the future. Software engineering skills are huge, along with system engineering. We are configuring routers today by hand because none of you have ever done this before. But possibly some of you know how to write code, and possibly none of you do, and that's okay. But I will tell you that going forward, the number one key that I would advise, aside from understanding the principles of network engineering, or possibly whatever tech sector that you're interested in, you want to study system and software engineering. Understand that as time goes on, it's huge. And filling in the Marco Pierre White quote again, microservices are also a thing that you're noticing now, where back in the day, maybe one thing was managed by one program. But then if something went wrong with that one program, the entire service just ceased to work. What we're doing now, or it's a lot more common in the industry, is to have a lot of little pieces added up to make something great. So you might have a service that's like, all right, this is the service that's going to monitor the traffic on my router interfaces. And then this is the service that's going to graph that information for a visual perspective for us to observe for monitoring purposes. And then another service that actually deploys the configuration on our routers and makes sure that they're all in sync. And then last but not least on this slide, cloud engineering. So a lot of networks nowadays, they don't have the need, the reason, or possibly the financials to buy all of this infrastructure themselves, co-located in a data center, and maintain it. So what they're doing is they're going to the hyperscalers like AWS, Amazon Web Services, GCP, Google Cloud Platform, Microsoft Azure, and they're running routers in the cloud, or they're running their network in the cloud, and they're having these services that they pay for effectively operate their network. However, to clarify, and sorry to step on grammar here, but they still need somebody that configures those devices, those instances in these cloud portals. So just be aware that depending on the role that you're interested in, you may need to know how to configure things in AWS and GCP and Azure. It's becoming a huge part of the industry in terms of another sector of network engineering of we're not configuring routers by hand, we're not even configuring our own routers. We're possibly configuring things in a web portal. And I linked a talk in these slides that was actually just given at the last NANOG just a few weeks ago in Atlanta by a fellow friend of mine, Cam, that talked about this in a more in-depth perspective. So here are some bookmarks that I will try and race through. NANOG has all of the talks and presentations and as well the slides on their YouTube channel going all the way back to NANOG 13 or 14, which was like early 2000s, late 90s. Apologies if I'm not giving the specific date there, but there's so much rich content on that YouTube page. Highly recommended if you're interested in network engineering. There's so much there. Likewise, the NSRC YouTube channel, the Network Startup Resource Center, has pretty much everything that we covered today in kind of step-by-step broken up videos, 2 to 5 minutes long, that you can go visit and learn about BGP again and other principles of network engineering. NANOG has their own mailing list that is incredibly useful information that literally steered the direction of the internet back in the day and still today, as well as a lot of troubleshooting. You can find out so much information just by subscribing to that list. Anybody can send an email to that list. You can also literally view the archive of that list going back into the late 90s. A friend of mine runs his own mailing list for operational purposes. I put his mailing list link there. Container Lab and GNS3 are ways that you can virtualize router devices. And then Route Views is a way that you can actually log into a router that is a bunch of different interconnections to ISPs. That you can literally view like the global internet and how it's currently operating. You can interact with routers when you go home by going to that web page. It'll tell you how to log into them, and you can get observability information. RIPE does the same thing. There's a few information. And PeeringDB talks about different infrastructure and where they're located in the world. And that's my time. So thank you all, everybody, for coming here today and listening to me, and it's a pleasure. Thank you.
Okay, thank you very much, Aaron. I hope you all found that really interesting. Good news, it's time to eat. Come on, get up, go on outside, get some food. We'll come back in an hour or so. Thank you. Okay, I'm being told to wait. What's up? All right, everybody sit back down. Okay, sorry about that, my friends. We had a miscommunication. My fault. I apologize. We have to wait just a minute or two, just a few minutes for lunch. So, Aaron gave a good talk, and there is something I want to say about that. But first, I want to give you the opportunity, which I promised you I would give. You heard Aaron talk. You heard him talk about his upbringing. You heard him talk about how he got a job. You heard him talk about some of the things he's experiencing in his job. Does anyone want to ask Aaron a question? You can ask him anything you want. Okay.
All right. This means it either went really well or really bad. Or both.
Good afternoon. I think a young man has his hand.
Okay, who had a question?
So since you said you're interviewing people, besides people overcomplicating or putting irrelevant information into the resume, is there any other thing that you would instantly make you say, nah, I'm not hiring this person? Is there anything else that people should avoid?
Sorry, can you talk a little bit louder and closer to the mic? I heard about resumes and like, do I recommend what to put into resumes? Is that the question?
No, it's you recommend us to try to summarize our information when we put in our CVs.
Yeah.
Is there anything else, like, what is something else that when you would watch someone's CV would instantly make you think you don't want to hire them, besides overcomplicating it? Is there anything else people should avoid doing to their CVs?
So like, what are some key parts of resumes that stand out to employers that, you know, are looking to recruit?
Both positive and or negative.
But past what?
Positive and negative. Things that stand out for
Good or bad?
bad reasons, yeah.
What are some good and bad things? Okay. So the main part of that object on the slide was that sometimes I get resumes that are like 3 pages long, and it's just a lot of information overload that, you know, we're looking at these resumes possibly like 5, 10, 15 at a time, and we're just looking for bullet point items where if it's 3 pages long, sometimes it's just like, all right, it would be a lot easier for the employer to, like, I grew up with, I know this is contested, but I grew up with saying that the resume should only be 1 page, one-sided. Other people would disagree, but that's my perspective. I didn't want to say that earlier, but so yeah, I mean, like that's what I think is best. Just have bullet point items of effectively possibly like 3 to 4 things that you did in that role. So like usually it's like, all right, my name, education, the past like 2 or 3 roles that I've had that are specific possibly to the job, and then volunteering. Volunteering is huge. We love seeing volunteering on resumes, possibly extracurricular activities, hackathons, NOGs that you attended that possibly had hackathons associated or activities like this. You can literally put this on your resume of saying, I attended CaribNOG and I learned how to configure ISP networks at CaribNOG. Like that, you know, we can brush up the title of that later, but that's huge. So.
And let me add something to that, as from the perspective of someone who has been hiring people over my career. The resumes that I pick out of a stack are the ones where when I read it in 30 seconds, I'm getting a sense of who you are. When you're writing your resume and putting together the experiences that you've had, the skills that you've had, the voluntary things that you've done, if you make it your own, so you find some words so I know who you are, so I know what's important to you, or I know the most important things in your past and your present, that comes across authentically. And when I read an authentic resume, I'm much more interested in it than an inauthentic. Because when I'm hiring, I don't look for the most qualified person. I'm not looking for the person who can check all of the boxes. I'm looking for the person who's going to fit well in the team, or who is going to be a leader because I'm hiring them for a leader role, or someone who's going to work really hard because I've got a role where they've got to work very hard every day. It's not about being the most qualified. It's about being you, because if I'm looking for someone like you, that has to show up on the resume.
If I was to put it in one word, it would be passion. Can I see off of the page that you're passionate about this field? Because that, I know, is that you're actually going to have the most involvement in your career, in your work capacity to get the job done, because you care.
Okay, we have a question over here. Oh, see? Comes with his own mic. That's neat.
I just want to ask, like, if you had to start over your career from scratch, what advice would you give yourself? Or what things would you do differently if you had to start over from scratch?
Gotcha. So the question was, if I was to start over from scratch, what would I do differently? All right. So first thing, in terms of financials, I would attend a junior college first. Going to a four-year university is very expensive. I'm in a whole bunch of debt. I'm not afraid to say it. Junior colleges, at least in the States, are a lot cheaper, where you can go there for 2 years and possibly progress to a university for a lot cheaper for the last 2 to get the undergrad degree in 4. So that is definitely one. I would have at least cut my student debt in half, if not more. The second thing, kind of what I talked to about of the race or the pace thing, feeling behind and that really weighing on my mental health, of saying that like I'm behind or I'm not gonna be where I wanna be at 25 or 30 or whatever. It's okay, right? Like we're imperfect beings, and don't compare yourself to anybody. Besides that, I would have definitely focused on more software engineering skills at an earlier age, without a doubt. I work with some people that are like, yeah, I learned C, which is a programming language, at like 16 because I grabbed a textbook and I was just interested in it. And I'm like, I wasn't doing that at 16, but like I would have been better off if I did. So software engineering skills for sure. Those are like 3 key things.
So I want to add to that, because he said something that was really key. He wishes he had done software engineering skills, and he wishes he had concentrated on that more. Well, are you concentrating on it now?
Yes. Yeah, without a doubt, it's at least like a third, if not more, of my job. It's a necessity in this industry as it keeps going forward.
And that's kind of the point. One of the mistakes I made in my career was I got a job and I mastered it. And I was really good at it, okay? And then I got comfortable. And I didn't realize, I wasn't paying attention that I need to learn new things. The job's not asking for it, but I got to pay attention to what's happening around me, and I got to learn new skills because we have to keep growing. Where's Mr. Kenny John? Kenny John's in the back. But Mr. Kenny John, who's in the back there, he says something very important. If we don't try something new, we don't grow. And that's so true in life, but it's definitely true in engineering. It's definitely true when you're a professional, so you've got to keep growing. Okay, we have next question from my friend over here.
And just to tail on to that real quick, like I said, back in the day, when I initially started off, I feel like I was right at the crux of people configuring routers by hand and moving completely to automation as like the focus. So that was what I was so focused on, is understanding the fundamentals, the protocols, and so forth. But widening those horizons, having a spectrum of education, including software engineering in that, would have been really helpful.
Which would you recommend, a certificate?
Can you speak louder, please?
Which would you recommend, a certificate or a degree?
What's more important, a certificate or a degree? That's a hard question.
Yeah. All right. So your goals are what matter there, right? If you want a college degree and that's something that you care about, possibly something that your parents care about and you want to accomplish for them or yourself or whoever, you got to do it, right? If, financial cost is the specific perspective, certifications are obviously a lot cheaper most of the time than 4-year degrees. So be it. What I have noticed more and more as I've aged in this industry, even while attending NANOGs and various NOGs and hearing a lot of smart people in the room that I'm working in or at conferences, is that I feel like certifications actually help you in continuing education, of saying there's possibly this new buzzword, this new sector of the industry, this new thing that we're doing with routers or how we're constructing or architecting networks that I didn't learn in school, I'm not currently doing in my job, but people are going to be looking for in 5 to 10 years. If I take this certification now, even though I got a degree, 5 years ago, I'm going to get refreshed on principles that I learned, and then possibly some salt on top, some sprinkles on top of new stuff that I wasn't aware of that I'm not currently doing in my current work capacity, but are going to be very important in 5 to 10 years.
If I can add something to what Dave already said, it's that I come from Latin America, right? And I always said that we, Latins, we didn't learn historically. This is kind of in our DNA. We didn't learn how to separate work from feelings, from family. We try to separate them sometimes, but no matter how hard we try, we cannot do it. So I want to mention a couple lines about the feelings and about your personal goals or will, right? If you're going to study something just because the market is going that way, it's likely that at some point you're going to say, I'm afraid I did this. So never forget, no matter what you choose, no matter what you choose to do, no matter if you want to have a university degree or if you want to study a technical as a technician, certificates, isolated studies, no matter what you want to do, just my personal advice would be just follow what you really want to do. Because if you are in a job and you don't feel well in where you are, it just, yeah, maybe you should change jobs.
Completely agree. One more thing. Out of certifications or degrees, actually there's a third thing that I would highly recommend, which is projects, for lack of a better term. Showing initiative that in your free time you were so interested in this realm of this work, this industry, this profession, that you went ahead and you started doing your own projects. So like GitHub, a lot of people write software, a little tiny script that does a simple task, or possibly like a router configuration that they built, or a network that they built. You can upload those configurations to GitHub, draw a topology, draw how the routers connect, and talk about the lab that you effectively built, or something that you learned of like, I learned how to configure, today in a workshop, but if you go home and you can draft this yourself and show possibly other people, that's huge that you can show that, like, you can show your work. Like, for example, when we were doing math homework when I was a kid, if you just wrote the answer but none of your work, the teacher wouldn't give you full credit. So if I can see that, you're taking your time off to spend working on projects, that you can upload in some manner that can be observed by people publicly, that I think, showing experience effectively is what I'm trying to say is huge. So I would say that outweighs all. And I think I put that in my slides, if I'm not mistaken.
Okay, we got 2 more questions. I think we have one over here, please. Yes, ma'am. The purple mic.
What resources would you recommend for those of us who are not currently in school for tech subjects, but we want to learn like software engineering skills?
So for software engineering skills, apologies, I didn't put those on the slides, but there's a variety of different websites that kind of break up principles of software engineering into different lessons that are free to the public. One of the most popular ones is leetcode.com. I'm going to update my slides, that bookmarks one, and put some of them in there, so you can all access that later, so just no worries about that. But LeetCode is one of them. So you go to leetcode.com and you can start I want to learn Python, right? And they have hundreds of lessons that they break down into little tiny chunks. You do one a day. In 3 months, you'd be astounded with how much you understand if you kept that pace. Not trying to consume it all at one time, but learning it gradually. Another one is Code Academy, and then if other people can help me out here, HackerRank, I think, is another one. Somebody's saying something I can't hear. Anyway, so those are some resources where you can literally learn how to code for free online at your own pace. And I'll update my slides.
Who was it here? Anyone wants to add anything? No?
You have a question?
Oh.
You have a question?
Okay, so we have an anonymous question.
It's more of a comment on the following.
So someone has asked, when you're going for your first job interview in the engineering world, what do you wear? And that's a really interesting question, because come here, my friend. We don't look the same, do we? No. He looks more like an engineer. I look like an old man.
I'm somewhere in the middle.
And, you're the man in black. I have an answer. I want to hear your answer. I will tell you, I'll be totally honest with you, it's not easy. But first, your answer.
Yeah, so if you are going in person, it might be scoped to the role, right? If you're focused on, careers in tech involve sales, for example, right? We need somebody to sell these products. It's definitely more of a business role where you're expected to wear, a button up with a collar, maybe some slacks, business shoes. If you're going for an engineering role, I would still try and be business casual at minimum, right? Because effectively what you're showing is effort, right? How much did you try and prepare for this interview? So it's hard to overdress, right? Even if you came in a suit, I'd be like, wow, this guy really cares. He's really trying to, But even if not, you'll find that in the workplace, a lot of engineers, they're literally wearing hoodies and possibly shorts and sneakers or tennis shoes to work. Keep in mind as well, you might be interviewing remotely. In that case, you only have to worry about the top up. So make sure the hair looks nice. Maybe wear a collared shirt. For women, I'm not sure.
Right. So it's been a little bit different for me because I spent most of my career in shorts and a t-shirt because I was building stuff, and you weren't paying me for what I looked like, you were paying me for how well I did my job. Because if you were paying me for what I looked like, you need to pay me a lot more money because I'm good looking.
Okay, David.
Nalia?
So it's okay to show up at a job interview in a suit and a tie. It's okay to show up in a pantsuit and a jacket, or a skirt and a jacket. It's totally okay to dress up because that shows you care. That shows, hi, I'm a professional. It's also okay to show up in a plain, simple pair of pants and a button-down shirt or a blouse. That's okay too. What matters is that you show up and that you smile and that you're nice. And also, please make sure you've showered. Nayela.
Morning, everybody.
Thanks,
Morning,
David.
everybody. Morning, everybody. I know that the time is nigh and you're hungry, and we intend to feed you. Just before we do so, some housekeeping matters. When we do break, kindly make sure that you adhere to the time limit. Who am I? My name is Kenny John. I'm president of the Grenada Chamber of Industry and Commerce. We are proud to be the host. These lovely people who have spent a lot of their own money getting here and their organizations. Yes? The least we can do is give them a little food, right? Right. Careers. I'm proud to be also the CEO and chairman of Antillean Group, that banner that you see there. We're from Grenada. Everything that you see was created by Grenadians. From the name of the company to the artwork. There are two gentlemen here who are actually from my company. A little big for students, but Presley, say hi. Nathan, yeah? We have a IT department, which is different from an IT person. And so you have to think about what it is and where it is you want to be. There are loads of us who enjoy messing around with software. But when you get out there, it's about practical application. So I couldn't help hearing the question about, okay, should I go certificate or is it that, I should learn by rote? Skill level plays a high part of it. However, I will always encourage you to get a certificate. Why? It opens doors. It opens the doors in the theory that when you get into the real world, and you may find that practical application, just like the namesake of technology. What is technology? The practical application of scientific knowledge. It means, therefore, that it's not just when you get into the workplace, it's not just about computer science. We're an insurance company. So we move and control and manipulate massive amount of data. I'm proud to have had one of our systems in one of our companies created right here. And it's a monster. Yes? What I'm trying to say in short is that we tend to look outside for inspiration and think that things are necessarily better in outside. And outside I'm talking about with big companies, etc. But the truth is that most organizations, be it the United States, be it Europe, be it anywhere, actually made up of small and medium-sized enterprises. And so having solutions, yes? Creating solution. This is all about creativity. We started from scratch, including the IT department. And you have to decide for yourself, where's my passion? And whatever I get involved in, what is going to be my passion? So if it is ultimately that you want to be a programmer, fine. But get into an organization, and what I heard is unbelievable here. Volunteer. Yes? Try something other than which you have otherwise grown accustomed to or that you have mastered now. Because the world after this in IT is all about practical application. We're solving real life issues and problems here. And it's vast. Sitting here, one of you could be the next person who invents a software for a medical tool that is used now. But in 20 years' time, you can create a software that looks at microscopic, oh, this one's better, to make dentistry, to go to the dentist and have your fillings or whatever, much less painful. Why am I saying that? Because the world's your oyster. And you are the fortunate ones. And that's why the Chamber is so proud to have you sitting here as next gen. And what is next gen? You are next gen. Yes? Oh, don't look at me. I'm a crap end user. But yes, I am a crap end user. You know, sitting where I am, you would think that, oh, I'm not techie, not in the least. But so you guys have to be able to make things to make me look good. So I can get my one report for a quarter that spells out everything. It takes creativity. So, without further ado, I think we're ready now.
Are we ready?
So, without further ado, I think the lunch is ready. It's set up. Thank you for your patience. You may hear a bit more from some of us in terms of career paths and so. Remember, you can do it right here. So, without further ado, kindly, you can stand and orderly go out. It is buffet, and you will be served in terms of when you go to the buffet, you will get your plates and line up orderly and actually receive your food. So thanks. How do you find the session so far? Yeah? No, I'm not hearing you. We're from Grenada. We loud. Yeah? Excellent. So let's get something to eat and come back to the afternoon session. All right? Yeah. Seated at 115. 150. 150. Yeah, sorry.
check 1, 2.
All right, so as you sit back down, go ahead and get in front of your laptop. You'll see you're on a white, most likely on a white screen with stuff that you weren't expecting, and that's okay. All it meant is it timed out. The client times out after an hour, and of course we were out at lunch. So what you're gonna do is on that white screen, go ahead and close that tab, close that browser tab, make it go away. Then go to the group screen where you have the network topology, and just go ahead and click on the router again, please. And that will open up a fresh client. All right, I'm looking around, I'm seeing fresh clients spawning. This will put us back into the router. All right, it looks good. So now we're going to continue. We're going to go take a look at the packets going back and forth between the router and the border router. And to do so, Nicholas is going to have our next command. Nicholas.
Okay. So before we continue with that, I'm seeing some groups are still to bring up the BGP, connect to the BGP and the BGP session. So I will call those with assigned group 30. I repeat, 30. Just raise your hand. Who's group 30? Okay. He will help you to bring up the BGP session, because I'm seeing that your BGP session is not yet up and running. And also, whose group? Okay, let me check. Okay, no, that's all. It's only group 30. Only group 30 needs some help in. The others are up and running. Okay, so all of you should be in your routers like this. Okay? The next command, I mean, we're going to issue again the same command we used before going lunch to start to heat up again. So we're going to show space BGP space summary. And you press enter. Okay? Remember we have the section for IPv4 session. We have the section for the BGP IPv6 session. This is the section for the IPv6 session, BGP session. Here's the name of our neighbor, so the router, the border router we are connected to. This is the autonomous system of the border router we are connected to. This is how long this has been up and running. See, we went lunch. It's been 2 hours, 41 minutes, 56 seconds. This session has been up and running. Okay? You should see some 2 hours and something very related to this number. And then we have the number of prefix we are receiving, the number of networks our neighbor, our border router, our friend is telling us, and we are sending him the same amount of networks because we have no new networks connected to our router. Okay? Perfect. But these are totals, right? These are not the actual networks. So what if we want to really see what those 26 networks are? Okay? We need a new command. So now we will issue the command show BGP. That's all. Enter. Show BGP and press enter. And the screen is going to go up very fast, and it's going to show let me do something here, because I believe we are in the, this is, okay, so.
Oh, you're in a group, or was it just 30?
Okay, it's okay. Oh, no, just 30, just 30.
So there's something wrong on the border router. It says bad PRAS. The PRAS is configured correctly, 650030. So it must be not configured correctly on the border. It says 00X in the lab. So then they just put 30 after that. Should there be
what's 5?
Should be, so, you know, like the template is 650X, right? Where they're supposed to put their group number for the remote AS.
It's 00. For group 30, it's 65030. Perfect. So, after we issue the command show BGP, what the router is showing us now is all the networks that the router knows. All the networks that the border router tells us he knows, now we know them. Okay? You see here at the end of the screen, if we scroll all the way, it says that is showing 26 routes. That is exactly the number we were seeing of the number of routes we were receiving from the border router. And each of these with an asterisk it's a network. So this router, let's take this one. This router knows about this network, which is identified by the IP B6 address 2801 1B8, and then it says /48, as we've heard from Aaron. That's this IP plus this. It's what we call a network. Yeah, it's a group of IPs. Okay, that is now known by our router. Then we have. Let's go up to the beginning of the routing list. Mainly showed. That's it. Perfect. Okay. So if you go to the top of the routing list, you're gonna be. This is the IPv6 section, and it's the IPv4 section. But let's stay here in the IPv6 section. It's the same. We have a show BGP command. Then there's some headers here. We are going to briefly talk about them. So you see, here is a network. Now we know this network. And you see here is an asterisk and this sign, right? Mention done. So what does this mean? You go to the header and you have the meaning of each of these symbols here. So if you find an asterisk at the beginning of the network, that means that that network is valid. Actually, that means that that route is valid. And what is a valid route? A valid route, it's a way for this router, for each of your router, to reach this destination, this network, for real. What I mean is that if your router gets a packet that has to be delivered to this network, it has a valid route, so it has a way to reach this network, because it's here. It's in the this is called the BGP routing table, and it has an asterisk, so it means that this path, this road, let's say, to that network is a valid road. It's a valid path. Okay. Then you'll see this sign here, okay? That again, if we look at the header, this means best. It's the best route. Not only it's a valid route, but it's the best route. Why? Because we can have, as Aaron mentioned earlier, we can have more than one path, more than one road to reach the same destination, right? As if you are driving your car, you have different roads you can go, different paths you can follow to reach the same destination. It can be that there's only one road, but it can be that there's more than one. If there's more than one, this means that this is the best. So this is the one that the router is going to use in order for the packets to reach this destination, okay? Basically, it will send the packets using this route here, okay? Then, this thing here called next hop. What is this? Okay. Suppose that you are the router, you have a packet, You have to deliver the packet to this network. You have this valid and best route. What you do? Your router has different interfaces, right? Different exit roads to send the packet. Which one you should choose? Among all the, you remember that we have ETH0, ETH1, ETH2, okay? Here, the route will tell you which of those interfaces you, the router, should send the packet through. So, there's an interface in this router, in your router, with this IPv6 IP, right? And you have to send this, the packet you have to send to this network, it has to be sent through this interface. So this is the network, the destination, and this is the interface you have to send the packet through. So that package going to this destination is going to exit your router through this interface, the one with this IPv6 IP, okay? And this here, at the end, is something that we call AS path, or Autonomous System Path. What is this? This is the path that you will follow across all the internet from your router to this network. And you see here a lot of autonomous systems, right? You see, you have to carefully look at this. You'll see here the zero, this zero means your autonomous system. This zero represents your router, okay? Then you see autonomous system 65000. Does anyone remember who is this autonomous system? Who's this? Someone raise a hand and answer the question. Come on.
The BGP router?
The border router, you mean? Okay, yes, she's right. It's the border router. It's not your router. Your own router is represented by this zero. This is the next router, the border, because you set up a BGP session between your router and the border router. This is the next router. This is the autonomous system number of the ISP that is giving us, the lab, internet connectivity. This is the next autonomous system. This is some carrier or ISP that is giving the ISP internet connectivity. And if you follow this path, finally, this last number here, in this case, 10745, this is the autonomous system where this network lives. So this is a network that is part of this last autonomous system in the whole path. So what is this? This is the road the package will follow to get from your router to this network through the whole internet.
So let's put that in practical terms for a second. You pick up your phone and you go to YouTube and you watch a video. So I said at the beginning of the day, we were going to understand how that happens. This is how it happens. This network is a bunch of IP addresses in YouTube, for example. And this has the server that has the video that you want to watch, which means that network is, YouTube is 10745. So to get from your phone to YouTube, you got to go from here to another network, to another network, to another network, to another network, and so on until you get all the way to the zero. And that's how it happens in the real world. Whether we're in Grenada or whether we're next to the data center where this stuff is being stored and broadcast from, we go through multiple provider networks, multiple autonomous systems run by different companies just to get every single data packet with every single piece of video in it. So it's so important when we build internet infrastructure that we understand we don't connect to YouTube directly. If you're on Digicel, if you've got a phone on Digicel right now, Digicel is not connected to YouTube. It's connected to whoever this is, who's connected to this. It's a mesh of networks. Yes, sir?
Wouldn't it be cheaper and a lot faster if you connect directly to YouTube?
Thank you. Yes, it would. So Aaron talked a little bit about, it's called peering. So, Brent McIntosh. Brent, come here, my friend. There's a gentleman, he's walking here right now. Brent runs something that's really important on this island. Brent runs the Grenadian Internet Exchange. This is a data center. Brett will tell us where it is. This is a small data center here on the island where Digicel, right? Yes, maybe? Is Digicel up here?
Yeah, Digicel appears as well.
Thank you for saying yes. Digicel has appeared. They've put a server, a router. They've connected to a router, if you want to be particular, in the Internet Exchange. And you know who else is there? Content providers. Let's pretend YouTube is there. They're not, right?
Not as yet.
Not yet. They're going to be, I promise, because Brent is going to make it happen, and I'm not fooling you. It's really going to happen. So what happens is YouTube puts a content cache inside the data center. And then when you go to YouTube, many of the videos that the algorithm knows you want to see, they load them into the content cache every night. And then you are directly connected. It is the Internet Exchange points, and it's this idea of peering where we create more mesh, more points of interconnection so that it's cheaper and faster. When Digicel has to go on that big line that you saw, it actually costs them money. They have to pay transit fees. If they directly connect to YouTube and appear, they don't have to pay the fees anymore. It's cheaper for the provider, and it's faster for the users. And so what we do in this industry a lot is we go around the whole world and we build these peering points, these internet exchanges, because that's how the content gets to us faster and cheaper. Brent, go.
Okay, great. Good afternoon, folks, and great speaking to you this afternoon. I was actually not prepared to speak at all today, but I'm glad I got the opportunity to speak to students, because I love speaking to students, because I was a teacher. I started my career in teaching, and I didn't find networking. Networking found me, and I just took it from there. So we're speaking about an internet exchange. An internet exchange, and you probably got a lot of detail already, but it's an infrastructure that allows countries that have ISPs, major enterprises, whoever owns two critical pieces of resources called an IP address block, an autonomous system number, to exchange traffic locally. Grenada has an internet exchange. By show of hands, who knew that? Wow. Wow. 0.5% of the seminar. Okay, great. So if you look at the screen, this is a portal called Pairing DB, a pairing database that contains information about every internet exchange point in the world, right? And in Grenada, we have some host, guest, participants on our internet exchange that pairs BGP with each other. So what happens when they do that? They have the best or shortest AS path to particular networks. Well, let's see who's on the Grenada Internet Exchange. We have an ISP by the name of ISCOM, you know them as Spice Mobile. We have Akamai Technologies, one of the global CDNs that provides around 30% of the world's internet content. I bet you didn't know all your Microsoft and Linux updates come straight from Grenada, right? And that's what happens with internet exchanges. We can go on and on, right? There are quite a bit of, if you could just scroll up a little bit. Yep. So we have, Cloudflare, which is another major global CDN, a content delivery network. The ISPs and so on. So if you have internet access on your machine right now, can you open a command prompt? Maybe you do the Windows R, but you guys know that stuff, right?
These are Chromebooks. These are Chromebooks.
Chrome. Oh, yeah.
Yeah,
Chromebooks.
they have to use a web-based.
Okay. So you don't have that utility. That's fine. So in other words, every member on the Internet Exchange can decide, well, I can pair with particular members. So in other words, if I want to send traffic, so in other words, let's take, for example, Digicel Grenada. Digital Grenada decides, well, I want my end users to send traffic to cable and wireless customers. And there was no IXP. There was no IXP then. The digital traffic would go through the internet connections that it has to Miami or sometimes New York and come right back down into Grenada. Now, that's not really efficient, right? I'm sending all my traffic outside to get back in. With the internet exchange, then Digicel would say, hey, cable and wireless, I want to pair with you. But before they do that, they would go on ParentDB and they would look at the parent policy of that provider. Digicel, being a large ISP, has a selective policy, which means that, hey, I would actually choose who I want to form a relationship with, right? That means I'm kind of picky, right? I'm in your party, but I won't really dance with you. I want to dance with somebody else. If you see Cloudflare has an open policy, and CDNs usually do. That means I want to pair, I want to connect with everybody in the exchange. So, either way, Digicel decides to call the guys in Cable and Wireless. Can we pair with each other on the Grenada Internet Exchange? Yeah, let's do that. So, just like you did today, they set up a BGP session with each other. Now, you have a shorter path to local networks. So now, when a Digicel end user or Cable and Wireless end user or customer wants to send traffic that is meant to go locally, it would no longer go through the US. It would go through the Internet Exchange. And if you had the ping utility, as a matter of fact, let me see what website I can give you. And again, I wasn't paid to do this. Go to www.grenada-co-op-bank. I think it's co-opbank.com. You got it, right? CO dash, it would be hyphen, right, I think, yeah. I think it's already in your search. Yeah, that's it. How fast did you think that site took to load? It was fast, right? Now, Grenada Core Bank is actually on the Internet Exchange. So, in the past, if you wanted to actually get to their content, go to the US and back in. Now, you access their front end directly from the Internet Exchange. Now, that's efficient. What does that mean for Grenada Core Bank? Anybody want to give some feedback on that? What does that mean? What does that mean for consumers, for businesses? The more services I can host locally, the better for me. What if there was an outage on the links leaving the ISPs to get to the internet? Well, my content will still be available locally. Internet exchanges provides a platform and optimal routing for traffic that is meant to be accessed locally. Let me give you an example of a situation where there was this particular client that believed in, I'm going to buy links that are cheap. So they have a head office. That client is actually, or that business was actually an insurance business in another island. And they had about 5 internet service providers in that country. So they had a main office and they wanted to connect all the other offices, all right? They wanted to connect all the other offices. So they would go to the providers and say, can you give me a quotation of how much it would cost to get an internet link or internet service so I can build my VPNs on? They would get 5 quotations. They would take the cheaper one. So the link from the main office to remote office or branch office number 1, maybe you would use provider A. Then they went to provider B and so on. So they had multiple offices connected by different ISPs. And then they built their VPN or their secure communication tunnels between each other. Every time they sent, or requested information from their servers, it'll be slow. Why? Because traffic has to go to the US, come back in, which was meant to go between St. George's and Grand Anse, right? Is that efficient? No. Why would I want traffic meant? Now, that country then got an IXP. And now, after the providers started exchanging their prefixes between each other, the VPN services became spot on. No, there were no more delays. Everything worked fine because traffic was crossing the local internet exchange fabric as opposed to going what we call upstream through the US and back. Now, that's just one application. That's only a single application. As a matter of fact, that was the traditional benefit of internet exchange points. Today, it does much more than that. Internet exchange points, and in the case of Grenada, provides critical services. We host eRoute and dRoute DNS servers. We host, a domain registrar. Their instance, we host DNS resolvers. For example, if I want to go to yahoo.com, I'm not really going to a name. I'm actually going to a number, right? But do you think you can remember the value 201:ABCD:1F20, as you will see with your IPv6 addresses? Would you remember that? You wouldn't, right? But you remember name. So the DNS server has the job of translating between name and number. We actually host the Cloudflare 1.1.1 DNS resolver and also Quad 9, 9.9.9. These are two of the faster DNS resolvers. And that's why clients and customers and even the internet service providers in Grenada, they use those resolvers. So you get faster response times because they are hosted locally. And there are lots of other stuff, right? Some we're working on. Our latest venture, and there's a wonderful team that works on this. It's just not myself. We have other guys at the NTRC as well. I think Sean is probably here. Probably stepped out. And there's Lyndon who's not here as yet. But we're working on hosting new CDNs. For example, Meta, because Meta is doing more things now, right? And yesterday I was showing an example of our internet reputation as a country. These CDNs, while they provide you lots of services that you like your TikTok stuff, you like your WhatsApp, they do tons and tons and tons of analytics. They know you as individuals, right? As a country, they know what we like to do, right? So I gave an example yesterday of one particular CDN that pulls a statistic, pull metrics, and then they build their analytics and they make it public. And they show the top 10 domains, in common terms, the popular websites that we like. Anybody want to take a guess what the first one is? Okay, it's top 10. Just guess any other top 10. Anybody want to take a chance and guess? You must know because you're the ones going there. Google? Google was number 1. You looked at the live stream yesterday. That's why you know that. All right, Google is 1. Google is actually number 1. Well, it's Google, but yeah, pretty much YouTube. Yep. But TikTok, yeah, she's on point. All right? So Google, TikTok, and you're missing a very popular one. Instagram. All right, so you guys know it. So, and that's the point we were making, right? You know, globally, we have a reputation, and that's our reputation. We love to consume social media applications. And I was saying yesterday, what we're trying to do, again, that's another initiative of the NTRC. We want to ensure that we give the opportunity for people to build local content. As in Africa, the Africans don't care about Amazon. We love Amazon, right? The Africans build their own Amazon service. They're consuming their local content. They're doing their local e-commerce. That's where we have to try to get to. I was interviewed by our esteemed AV cameraman the other day. And he asked me, what do I think, I think it was related to what do I really want to see happening in Grenada from the perspective of content. And I told him, I think we need to find a way, which is very simple, very easy to do, to build content for our local performing arts. Tons and tons of talented people in this country who can sing, dance, act, whatever. And we have no way of producing that into some form of maybe reality show, some form of videos or whatever, and store that stuff locally on our GrenadaTube.com, hosted in our data center in Monjalo. That's what we're trying to get to, okay? How much time do I have now? Okay, good. So we need to start producing our local content and consuming our local content. And that's where you come in, and that's where this program comes in. So you're getting interested in doing things like that. I'm gonna put someone on the spot. She's not gonna be happy. I may regret it for the rest of my life. But I'm still gonna ask her to come up here because I want to give her a very quick interview, because we do have quite a bit of women in technology in Grenada. And two of them are not here. One just maybe graduated from TAMCC maybe 2 years ago. She did a Cisco class with myself. She's been recruited by a very popular IT company, and she's doing excellent. And I think Ms. Salfali who was here. She actually did some work with us in the Internet Exchange, configuring the Cisco switches and doing her web development stuff on her graphics. She's pretty good. Another powerful woman in tech. And then there's another woman I want to interview, Miss Erica McIntosh, if you could step up. I have a few questions for you. She hates the camera, but I have to put her on the spot. Right. So, folks, this is Erica McIntosh, woman in technology in Grenada. So, Erica, I have a few questions for you.
He's dead, right?
What got you interested in IT? And tell us exactly what you did before and what you're doing now.
So, I was introduced to computers in secondary school. I think I may have been in Form 2. And at the time, it was DOS-based computing. So you had your, what did they call that type of spreadsheet? I can't even remember, but really it was DOS-based. And myself and my sister had the opportunity to just take a class, and we did, and after that I was completely interested. Even when I was in Form 2 in secondary school, I knew this was going to be my path.
Excellent, excellent. So you see, she was introduced it.
Yeah, introduced, yep.
So my second question to you is, what are you doing now in your career? And it's a two-part question. And secondly, what is the most exciting thing you have worked on that you feel the most proud about?
Well, I started off as a software engineer. That is what I'm trained to do. That's what I studied in college. And I started writing applications in COBOL. You guys, I'm not even sure if you've heard of COBOL. This is old language. So that's what I started off doing, working at an insurance company. And then branched off into, well, back then it was just desktop applications. So there wasn't anything about web applications when I started off programming. And branched off into web applications. Started doing some dashboarding. So I worked in the US, came back to Grenada, decided that there were gaps in the business where I was working, cable and wireless at the time. I was still working there. And I figured I could use my first world experience to help transform the local business. And that's actually what I did, because when I started doing applications against a live database, no one had ever seen that before. So we had real-time information against our billing system to tell us, okay, if, let's take Antillean Group. If Antillean Group had a fault with cable and wireless, we right away knew that this fault was raised at X period and how long it was outstanding, so we can deploy technicians to Antillean Group. And we did this for our business sector. And actually, this helped improve our KPIs for Grenada in field services. Then I branched off into data mining. So pretty much taught myself, which is something I always say, if you like technology, you will just dabble in it. So I was never taught database management or data, I taught myself pretty much. So I went from building software applications to just teaching myself data engineering, and that's what I do today. I still dabble in coding, so I write Python scripts still for automation at work. I downloaded, you guys have heard of ChatGPT, and again, if you love technology, you will be dabbling with ChatGPT. If you're a software developer, hopefully you would have downloaded a key and started writing the utilities, because this is kind of how you learn, right? You don't have to know everything that's out there, but when something new and exciting comes up, you just run with it.
Excellent. And so let me add. So I was always into network engineering and Erica software engineering. Now, we happen to get married, and it's a good thing. I do a lot of work. As a matter of fact, at home, I use both protocols, internet protocols, as Nate would have mentioned, IPv4, IPv6. And Erica loves to work with technology on a whole, whether it's consumer electronics, whatever it is, right? So, of course, she has this app on the TV that she uses to watch her reality shows, because she loves reality shows, and it stopped working. It stopped working, right? And no, she's a software engineer, right? So that stopped working. And one evening, she said, Brent, I'm not getting through. I can't see those shows anymore. I'm sure it's a DNS issue, but I think it's related to that IPv6 configuration you have. And I'm like, what? She know about that stuff? She researched, and I felt, you know what? I don't like to be wrong, because I know everything. No, it's not the firewall. Everything is good. It's nothing to do with the routing. I went back, reversed the changes that I made. Oh, it's working out. Did you do anything? And I was dying to say no, but I, of course, So, and again, that's the passion that you need to have, right? And software engineers, and I'll tell you this, being in network engineering, I am now trying to learn certain things that I need to do to help me and my automation of making things work better. But it's difficult for me, right? But for her, it's an easier transition. That's why I would encourage, and Aaron mentioned that today, and I was so happy when he said that. Get into software engineering. Everything will become easier. Thank you very much, Mrs.
You're welcome.
McIntosh. I'm dead. And one more thing before I go, there's another powerful woman in ICT here. I know if I call her up here, that will be the end of me today. She's like a mother and mentor to me. I just want to highlight Miss Claire Craig, who is our major female CaribNOGger. She's another powerful woman in ICT. And if she can, Claire, can I get you to come up to say, thank you very much. So Claire is going to come up and give us a few thoughts on her work in ICT. Thank you very much, Claire.
Hi, everyone.
So Claire.
Yes, Brent.
I have had the opportunity to work with you on many wonderful projects, and I must say, Claire actually did quite a bit of research on internet exchanges, and the first thing I'm going to ask her is, Claire, can you tell us about your research work in internet exchange points and how you got started?
Okay, so I went to a meeting in St. Kitts more than 10 years ago, and they were talking about internet exchange points and IPv6. I have been in information technology most of my life. I went to university before most of you were born and studied. It was information systems and business at the time. Don't want to go into all of that, but I came back to the Caribbean. I studied in Canada, came back to the Caribbean, and worked in technology. I started off as a programmer. And then I became a systems analyst. And for most of my career, I have managed enterprise applications. But going to that meeting in St. Kitts, I found out about the side of engineering, which I knew nothing about. They talked about the fact that we in the Caribbean have no data to manage what we need to do. And as a result, I applied to the University of the West Indies to do a degree in social policy based on one of the cases was the Grenada Internet Exchange Point. And that is because Grenada is the internet exchange point for the English-speaking Caribbean, the first to be implemented. And I thought that it made sense to look at who were the stakeholders, what did they do, how is it working, and we continue to look at how it continues to grow. The second internet exchange point I did was Curacao, so I looked at two of them and compared them, which were different in their setup and everything else. But with the limited resources that Grenada had, they have done so well, and they continue to do quite well. So I hope I didn't talk for too long.
That's fine. Thank you very much, Claire. I remember in her research project, when she was completing her PhD, she interviewed me. She flew over to Grenada to interview me. And I'm usually very comfortable with talking about technology, but the question she asked, I was literally sweating in an AC location. So again, Claire, on one more thing, I just want to ask you this important question. And the question is, what advice would you give to young aspiring technologists like the folks we have here to ensure that they find a career or future within the ICT or technology realm? What advice would you give to them?
So two things I would say: do what you love, right? I think Aaron said that. Be passionate and go after it. And don't let anybody tell you that you can't do it. Because as I said, doing my PhD in internet exchange points had nothing to do with my job. It was just something that I felt I needed to do, and I continued to do it. And now I am retired from my job, and I enjoy coming to sessions like this. I'm also a part of ICANN, and and it really helps me to continue to be relevant. So I will say to you all, have a passion for what you're doing, and don't let anybody tell you that you can't do it. Just keep pressing in, and you don't fail unless you stop.
And that passion, I can tell you, I totally agree. I was always passionate about what I did, and it takes you to places that you can't even imagine. Being passionate about internet protocols and internet exchange points and internet technologies on a whole literally took us to places, and in my case, that I dreamt of. I never thought I'd ever get to go to St. Bart's. That's out of the budget for vacation. But internet exchange points took me to St. Bart's. We traveled and we did quite a bit of work implementing internet exchange points based on the model of what we did in Grenada. So Claire, my last question to you, my very, very last question is, what are your thoughts on young people trying to become experts at what they do? What advice would you give to them if they want to become an expert? Sometimes it takes just a little more than the passion. What else would you say to them?
Well, if you first to begin, talk to people who are experts in what you want to get interested in, and ask them how they got to where they got to. If you are academically inclined, and not everybody is, continue to study, continue to develop yourselves in whatever way you can. As Erica said, she is self-taught. So you can find the books, you can find, and everything is available for research. You can find out about it and, just go after it. Those are a couple of things that I would say to you. And again, don't give up. Keep pushing the envelope, and it will happen. There are people in the room who can help you, and don't be afraid to talk to certain people. As I said in a meeting yesterday, when I ran out I couldn't get some of the information I needed to do my research, and I went to a CaribNOG meeting like this, and I met Vint Cerf, who is the father of the internet. And he had given me his business card, and so I wrote to him, and I said to him, can I get some information? I need help with my research. He was, I think, chairman of Google at the time. He sent the email across to his colleagues, and persons actually wrote me back and offered to help me. There was one guy who used to come to CaribNOG meetings all the time. I can't remember his name right now. Several. And he said to me, Claire, I can't help you unless I get permission from Google. And when Vince sent that out, I was able to go and get the permission to do what I needed to do.
Excellent. Thank you very much, Claire. There you had it. You have heard from some of the most powerful women in ICT around.
Okay, thank you, my friend Brent. Appreciate it. That was very brave of you to ask Dr. Craig up and then ask your wife up. Very brave. Thank you. Okay. So all that because you asked a question. Good job. So now you see why we're doing this. Now you understand how your packets get from your devices to the sites that you're going to. Let's look at just a couple more things on the router. All right, Nicholas, what are we going to look at next?
We're going to skip some steps in order to do something interesting that we want you to see. We're going to go now. What we're going to do is we're going to look at a specific network. Actually, we're going to look for a specific IP, which is an IP that belongs to a network, which is the, and this is when we get fired, actually, but anyway, which is the ICANN web page IP, which is the IP number. Let me check. Let me make sure I'm not doing stuff wrong. So we are going to go to the router. Each of you is going to go to your router. Yeah. Once you are in your router, you're going to execute the following command. You're going to do a show IP BGP, and you're going to write this IP 192.0.32.7 and press enter. Okay? So it's show IP BGP 192.0.32.7. What's that? That's the ICANN public web server IP. So each time you go to your browser and type www.icann.org, your browser is going to get the content, the web page is going to be download from this IP, okay? You are in your router, you execute the command, and you will see this, right? What's this? This is the specific information from the router BGP table we already saw, but only for this IP, okay? What is this telling us? This is telling that this IP 192.0.32.7 belongs to this network. So you see, this IP belongs to the network 192.0.32.0/24. So this is an IP that's part of this network. What's the path from each of your router to the ICANN web server through the internet? Well, this is the path. You begin at your router, then you go to the border router, the one you have the BGP session with, then you go to this autonomous system, then you go to this one, to this one, to this one, this one, this one, and finally you go to the autonomous system 40528, which is the ICANN autonomous system where that IP lives, okay? So what we're going to do now with this, okay, let's go back to the tab when you have your network. You do it. To the other one. Yeah, that one. So let's go back here. And now we are going to use this device, the client. So click on the client. So you go there, place your mouse over the client and just click. A new tab is going to pop up, and after a few seconds, you will see this. Okay? Now, we are in the client. This is a command line interface of a Linux, Unix-like machine. We are going to use a command that it's an application that it's installed in this. It's a command line application that it's installed in this server that is called mtr. So we are going to type mtr, M like, yeah, M like mom. That's mtr space, and we are going to type www.icann.org. Okay, so mtr space www.icann.org. Okay, the organization David and myself work for, and Naela. And you just press enter. Okay, and what we are seeing here, this application is going to list all the routers, the packets from your computer to the ICANN web server are going through. So if you look at the first one, that's your router. Actually, that's the border router. Okay, that's the border router, the router you are connected to. Then you go to that router, that. So the information to go from your computer to the ICANN web server has to go through all of these 21 routers in order to reach the destination. You see? In order to reach this destination, the information is going through all those routers. Okay? Okay. Now, what we are going to do now, and I want you to pay the most attention you can to this, is we are going to try to perform a cyber attack. Okay?
Sorry, 1 second. So it's Mike Tango Romeo. Mike Tango Romeo.
MTR, yeah.
MTR.
Okay. Everybody was able to use this application, MTR, www.icann.org, okay?
Not November. Mike, M.
Yeah. Mike Tango Romeo. Okay? That's it. So leave this running, okay? And as I said, what we're going to do now is we are going to perform a cyber attack. What kind of attack are we going to do? We're going to do a cyber attack that points towards routing system. Actually, this attack points towards BGP, and it's called routing hijack. So what we are going to do, and it is for real, we are going to do for real. Hopefully we are not getting fired because of this. We are not putting down the ICANN site. I hope so. But what we're going to do is we are going to hijack ICANN's web server IP address. Okay? Yeah, as bad as it sounds. And you will see what happened in all your computers when you do that. Okay? Just wait 2 minutes. I'm going to try to perform the cyber attack, and we'll see what happens.
So some of you might be asking, what is a route hijack? So in terms of BGP, when we're announcing prefixes or IP groups from one network to another, sometimes due to misconfiguration or intentional malicious activity, a network will say that an IP group or an IP prefix is reachable from my network, even though they have no authorization to say such a thing. So that is effectively hijacking that route, where traffic would possibly be redirected to their network, where whatever content you may be requesting doesn't actually exist. So you type in www.icann.org, you're expecting a web page, and you're expecting the ICANN web page, right? But let's say I actually hijack that route to icann.org, and now instead of going to a true icann.org web server, you now go to my malicious web server, where I could possibly extort data, get you to download a virus, so forth, right? So I'll hand it back to Nicholas to, yeah, couple minutes. If anybody needs help, feel free to raise your hand. Yeah. Anybody else have questions? Need help?
Okay, so please go again to the client to where you have the MTR thing running, and press to exit the application. Press Control C at the same time. Control C. You will return to the prompt, and now let's do the same command MTR but with the IP address of the ICANN web server, right? Which is you have to use the command mtr, but now instead of writing www.icann.org, just write the IP address of the server. The IP address is 192.0.35.7, okay? Again, 192.0.35.7. Everybody there? Okay, then press enter. Okay? We see the same Only that now we are not seeing names, we are seeing the IPs. We have those, all of those routers we are going through up to the network where the ICANN server is, okay? Now, I'm going to perform the attack and you're going to see in real time what happens, okay? Just wait a couple minutes, like 30 seconds. Press R. No, just have to wait. We have to wait. It takes some seconds for the BGP to you know, for the thing to realize what happens. Let me check. That's it. It should work, right? You are using that IP? Yes. It's a correct IP? No way.
Just run one query.
Huh?
It's sending multiple probes, right? Continuous probes, so as hops change, it shouldn't have that route.
No, but they shouldn't. Strange.
I put the wrong IP, that's why.
Okay. Okay, let's do it again. Wrong IP. Yeah.
We just need to just have them type MTR 192.32.7.
Yeah. No, but I have to. I want to remove the. Okay, that's it. So tell them to correct the IP.
Okay. And I should tell them to rise? They should rise. Okay. Here we go.
Okay, so let's make this interesting, because thank you for bearing with us. All right, press Q, come back to this command line. One of the things that happens in network engineering all the time is we put in the wrong IP address. And look what we did. Ladies and gentlemen, please rise, please stand, out of respect for the Prime Minister of Grenada, the Honorable Deacon Mitchell. Welcome, welcome. Take.
One, two, one, two. All right, good afternoon, everyone. Good afternoon, everyone. All right, sounds more like it. I hope you're not falling asleep in the class after lunch on a Friday afternoon, are you? Yes? All right, fantastic. Please have your seats. Thank you. Let me also indicate that I have Minister Lennox Andrews, who is the minister responsible for what is called the super ministry in the government. He's responsible for economic development, planning, ICT, the creative economy, and tourism. And he's here with me this afternoon. We actually left a cabinet retreat to come across and say good afternoon to you all and to encourage all of you to continue doing what you're doing. I was here at the commencement of this, how should I call it, exchange on Tuesday or Wednesday? Tuesday. Right, so it's Tuesday, Wednesday, Thursday, Friday. So it's been 4 days. And I was told it was going to end with you students being here this afternoon. So I wanted to make sure that I came back to give you my personal encouragement and my personal support and to say thank you to the organizers and the sponsors who've made this event reality. I think you have an opportunity by doing this, as well as you go along in your career and in your education, to truly be a different kind of Caribbean person. In my time, I don't think ICT was even a acronym, much less something that was topical. Now it is, and you truly have the opportunity to be a Grenadian citizen on the world stage and to be able to earn a living from Grenada anywhere in the world. In my profession as a lawyer, I could only earn a living in Grenada, or I have to fly to another country to earn a living. Technology allows you to earn a living from anywhere you are in the world, working for anybody, anywhere. So it literally makes the globe flat. And so I want to encourage you to have fun, to take the opportunities you have for training and learning seriously, to keep the contact details of all of the people here you meet, and feel free to use them in the future so that they can help you get jobs, help you get further training, help you get further opportunities as you go along. So I just want to wish you best of luck and a pleasant weekend. Minister, you want to add a couple remarks? After me, yes, not a problem.
So thank you, Prime Minister, and a very pleasant good afternoon to all of you children. It's a very nice gathering. I can see the excitement on your faces. I can see that you are learning, so please make the best use of the opportunity. Thank you all very much indeed.
Thank you very much for your attention. Now, as he deserves, kindly stand as he takes his exit and his team, and give some one second. You want some quick picture? Yeah. Yeah. Actually, sit please, so we can. Yeah. 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 It's busy. Thank you guys. This is what we do it for. So everybody give a cheer. ICT Week.
Let's give the PM a selfie.
One more. It is a main facility. Thank you very much for saying. Sorry for making it hectic for you today. You know it is. You wanted to be here. This is what we have on 130. Give a round of applause. Good, thanks, man. Cool.
Thank you, Kenny.
Thank you, Kenny.
Did I forget to tell you about that this morning? No. Yeah. Okay, the truth is, my friends, we're at the end of the day. The truth is, we have shown you how to turn up an ISP. We've shown you why an ISP exists. We've shown you that it's really important that ISPs connect to each other directly, that they peer directly so the content goes quickly. Now you know when you pick up your phone and you go to a site and you use it, now you know how it actually works. And you can take that information away from here for the rest of your life, whether you become an artist, a writer, a teacher, a software engineer, or the Prime Minister of Grenada. Now you know how the internet works. Thank you all for coming. Thank you all for being a wonderful, wonderful class. You guys and girls were awesome, and we really appreciate that. And guess what? It's Friday afternoon. It's time for the weekend. So thank you, my friends. God bless.
Thank you to you.
Just want to say,
Just want to say, if any of you have any questions, if I'm not able to reach you directly today or anybody else here, just find us on LinkedIn or possibly after in the back. We're more than happy to answer questions.
Thanks. It looks like you don't want to go. You want to keep on trying stuff. Huh? The attack. Well, for those that desperately wanted to see what the issue with the attack was, that we were writing the wrong IP. The IP for the ICANN site is 192.0.32.7. So if you put that IP and press enter on the MTR, you'll see that everything is working. And if I really perform the attack, just let me issue the command to do that. It should work. Let's see. Yeah, that's it. If you press R, the R, like Romeo, the R key will refresh the screen, and you'll see that everything changes. And you will see that now we are no longer going through all those routers towards the destination, but we are only going through one router, through the border router. Why is that? That is because I took one of your routers, and I started to tell that router that I am that network. When I tell the router that network is connected to that router using the BGP protocol starts to tell all the other routers that he has that network. And because that router is closer than the ICANN's router, you see that ICANN's router is 21 routers away, and this is only one jump away. As this router is closer, now all the packets that were supposed to go to the ICANN website are going to this router. So I just hijacked the route. If I put up a web server in that network with a page that looks exactly like the ICANN one, you will see your bank account and you are getting into my page. Then you log in, and guess what? I steal your username and bank password. And you can find out what happened next, right? I get all your money. So this is a real attack. This is happening, you see. This happens in the real life. So there are many other protocols that we don't have time today to speak about that makes you or helps you prevent this from happening. There's a specific protocol called RPKI. We are not going through that now. That protocol will solve this issue and will make things start working again. Okay? If we have time, we can learn about that protocol, configure that protocol. It has to do with BGP, and by the means of that protocol, we can skip or we can literally avoid this kind of attack. Okay? Again, as David said, I hope you all enjoyed today. For us, this was amazing. And the premier, I mean, I think you're going to appear in all the newspapers from the country for the rest of your life. Yeah, a lot of pictures here. Anyway, thanks very much. Thanks for being with us today, and have a great week. Bye-bye.
Familiar with the NTRC? Well, this week we realized that the NTRC, the National Telecommunications Regulatory Commission, seems to be the best kept secret in Grenada. All that you've heard about the Grenada Internet Exchange Point, that's part of what is being done by the NTRC. We regulate the telecom providers, the people who have license to broadcast, the radio stations, television stations, and we make sure that the customers are satisfied. In addition, we support different projects through what we call the Universal Service Fund. So those at TAMCC would know that there's a network there which we support. We are very impressed with what has taken place during this week, and we wish to thank the sponsors, first of all, Co-op Bank, the CaribNOG, the Antillean Group, especially Kenny. Where's Kenny? Kenny John. Cable and Wireless as well. These folks have invested in your future. We want to make sure that the things which we did this week can have a positive impact. And based on the enthusiasm we've seen this week, we decided that going forward, we'll do something. We don't know if we'll call it a Science Week. It doesn't have a name, but we want to make sure that every year there can be something like this, where we can bring the young people together, get a hands-on experience, not necessarily in IT, but it may go into some other aspect of technology, trying to promote the whole science STEM, trying to promote this. So we thank you for participating, and I think, folks, we have the names and contact information and all that. Great. We're going to have a database. We're going to reach out to you one way or another and make sure that it doesn't end today. You had opportunities. If you look at the board, you'll see that the government of Grenada has established a Coursera platform, opportunities for certification in a number of areas: graphic design, project management, IT admin, customer service, digital marketing, data analyst, software development, cybersecurity. In addition, please exercise your curiosity. Do searches. I just got a message from one group saying that there's 17 spaces available for cybersecurity training outside of Grenada. So this information is posted sometimes on the NTRC website and different locations. If you're curious, you'll get great George. Yeah? Okay, folks.
Once again, thank you everybody for coming. The future of Grenada, can I have all your attention, please? The future of Grenada is actually in your hands. But yes, let's put it this way. Your hands are on the pulse of the world. Don't ever forget that. So, to organize... Yeah. No, just right here. Yeah, just rest it right here so we can sit. Should we blank that screen?
Good afternoon, students. Has anybody ever heard of ICANN? Just let me see a show of hands. A few of you. David works with ICANN, Mr. David. ICANN has meetings in 3 countries of the world every year. Those meetings are rotated. The next ICANN meeting takes place in Cancun, Mexico, the one after that in Washington, D.C., and the one after that in Hamburg, Germany. There is a way that you can get to go to those meetings with ICANN paying for your airfare and paying for your, paying for your accommodation, and also giving you a small stipend to take care of your usual expenses, transportation, and so on. It's called the Next Gen program, NEXTGEN. So all you do is you go to icann.org, there's a search box in the top right-hand corner. Type in Next Gen. The application round for the next meeting in Washington, D.C. is opened until the 31st of March. So you do have the possibility as students to actually apply and go to an ICANN meeting. But if you just wanted to find out a little bit more about what happens at ICANN, how your voice in the ICANN community can help shape the type of internet we have, or how your colleagues could benefit from participating in ICANN, do a search, find out about Next Gen, N-E-X-T-G-E-N, and just put a note in there saying that you came to this CaribNOG workshop. I will see all the applications, and I'll put in a good word for you, and hopefully we'll see some of you in Washington, D.C. Tell a joke? No, I don't do jokes.
Right, photographers. So everyone, what's your favorite slang? ICT week. No, that doesn't sound nice, does it? So what would make you smile? What would make you show teeth? Oil down? No? Money? Oh, well, we will talk about that with you guys another time. You have to know the value of money. Okay. You have some way to go. We talk after. You have to hold it, huh?
Who's holding the ladder?
Who's holding the ladder?
Hey, Jared, can you hold the ladder, please, when she goes up?
No, hold.
They really liked it. At the very end, they were checked out, which is why they ended it.
All right, we're about to take the picture, so we want you keenly focused on the photographer up there, particularly the lens of the photographer. And if there's anything that's blocking your face, if anybody's blocking your face, make sure they're not blocking you. And we're going to go ahead and take it, right? So pay attention, focus, lock in, and we're going to take a few, right? All right, we're going ahead. Lock your eyes, don't block your faces. I'm scanning. Tell me what we need. It's good? Back some more. Just give us 1 second, guys. Point it to the back. Yeah, that's better. All right, we're going again. Focus, everyone. Heads up, smiles, big smiles. You're happy to be here. You learned a lot. Looking forward to the next one. We light one in the back here for you. Just say when. Are we looking good? We're just checking. It's quality control. Just a couple more. Right, stay focused, don't worry. White cap there. Yeah, that's us. Good to go. Thank you so much.
One, two. 1 2 1 2. Can you please shut the top of the laptops and leave them right where they are so that we can take care of them? Okay?